Pierre, just say hi in the chat if you're ever in here, and we'll try to catch it. Although, full disclosure, we're suck at streaming.
Yeah. And we're not so much trying to get better at streaming as we are trying to get better at Holochain and Rust and all the other stuff.
Yeah. Hopefully, once we have our technical stuff a bit more together, it'll actually be really important for us to focus on the community aspect of this project. But right now, we're definitely still in the heads down, trying to get our infrastructure stuff
on
together.
Getting something worth building the community around built. But also getting experience on stream doing it.
Cool. Right. So what are we going to do today? We're going to continue going through Holochain guide. Try to find a Holochain sample app we can play with, and mostly that stuff, honestly.
Yeah, and maybe if we get to a point in the guide where it makes sense to start coding some stuff up, maybe we'll try to mess around with that, but we'll take it as it comes.
If it makes the sense. Okay, cool. That looks great. And this is, let's see, where did we leave off? Do you remember? We were reading about this Zomes stuff.
Yeah.
I read a bit on, but we should go back to where we were. Maybe we should review the Zomes quickly.
Yeah.
Where are the...
Let's see. Building on different platforms, writing in Rust, writing in assembly script, intro to assembly.
I also want to grab up that page that has the example apps in it.
Yeah.
Get that in there. That's the built with Holochain thing. That's here. So here's a bunch of sample ones. We can take our pick, but for now, maybe we can start by just reviewing Zomes.
Cool.
Right. Okay. So here we are. Here's the Zomes section. Zomes are... I'm going to try to sort of say it in my own words to see if I understand it properly. And yeah, so Zomes are like sort of a mix between just the regular sections of your app and also modules that other apps could use. So when you're writing a Zome for your Holochain app, it performs some function in your app, but it could also potentially be reused by someone else in their app, which is sort of interesting. So I think like kind of by default, that's the way they work. And they're kind of basically the whole function of the app will be made up of these Zomes, and then the Zomes get compiled into the DNA, which is the thing that sort of identifies the app in the gossip system.
Yeah, and they do some more than just like everybody run the same app, please. They do some cryptographic validation that people using the exact same DNA byte for byte are in the same network with each other.
Right. That's what lets them write to each other's distributed hash tables.
Yep.
Or each other's local hash tables that talk to all the other ones as they gossip. Right, so we expect developers to reuse Zomes written by others. So they sort of have a built-in API kind of thing. Rust is the main thing, but another cool thing is that because in the actual app, everything's just getting compiled to WebAssembly. You could have Zomes written in all sorts of languages, even inside the same app. Like you can have a Zome, you can have your app mostly written in Rust and use somebody else's Zome that's written in any other language, and that's fine. And even call functions from that Zome, I think. So it's kind of cool.
That is pretty sweet.
Right. So then the Holochain command line stuff comes with a way to kind of generate a Zome. This reminds me kind of Ruby on Rails a little bit, this kind of stuff.
Yeah, there's a lot of tools like that.
So that
will get you
useful.
a starter package.
It basically builds you a little fairly standard Rust.
Yeah, I think it runs cargo new for you.
Right, and so Rust kind of does two different default ways of categorizing what you're doing. One of them is a library, and the other one is, I forget what, basically an app, a binary. And so it's treating Zomes default as libraries, which is pretty interesting, and fits in with the idea of them being sort of like built to be modular.
And the reason that is because the app is actually Holochain, and Holochain is a bit of an interpreter for whatever we're building and compiling to WebAssembly. And so we are building sort of things that can be called, which is a library.
Right.
So
it all makes
perfect sense. We're almost we're building like a framework.
Oh, please.
Did I? Oh, hello.
Oh, you're better.
Okay, good.
Back. Right, yeah, and then so this stuff is all standard Rust, the source and the lib and the cargo toml, and this Zome JSON is kind of like the name for your Zome. So when it all gets compiled, this is the thing that's gonna kind of.
So I think Zome.json is metadata about the.
Right, that's a better way to say
it. And right now, the only metadata that they care about is the description. That will change as the project matures.
And as we'll see later as we go, there are a bunch of places where you, in the sort of main part of your Holochain app, where you're telling it which Zomes you have, and also kind of which functions you want to call from the Zomes, I think.
Yep.
And then this build thing, this is the only piece inside the code that is the actual Holochain thing. So this is the thing that's going to compile your Zome into the Holochain app. It's just a shell script. And that's not normal Rust. Okay, so mentioned above, textual to language Zome is written in. Right, this one extra file build.
Right.
Right, and then cargo is like the thing it's the package manager essentially for Rust. So this is letting you use other
package and build manager. Yeah.
Right.
It's very convenient.
Right. Many languages have a similar thing. Okay, let's go to the next page. Right, so HDKs. What does it stand for again? It's like Holochain Development Kit. So this is just a bunch of tools that help you use a certain language for development in Holochain, and there's currently a Rust one. I believe that's the only one right now. It's still like alpha or something like that, I think. But this is what we'll be using if we build this in Rust on Holochain. There's a whole thing on it. You get to set the version that you're using. I think 0.0.3 is the current stable, and then there's an 0.0.4 alpha. And you call it as a, you import it as a crate in Rust, and then that lets you use a bunch of Holochain functions.
Right.
And then this whole macro use thing, which we don't have a great understanding of yet, but it seems that macros are a very important part of Rust.
Yeah, I think. Yeah, I'm not actually so sure about that macro use thing or what that means about the HD crate. My guess is that it's got a bunch of macros in it and we're going to use them.
Right. So one thing that I have seen from reading on it is this define Zome macro seems to be fairly useful. So
yeah,
I think there are probably a few things like that. Okay, next page. Right. So Zomes have a bunch of things that you need to have in every Zome: a name, a description, a config, which is not implemented yet. Validating entry types. This is like one of the most important pieces of it. We'll get to it more later.
So yeah, I did a little bit more digging into entries, and actually that video that you shared with me from the old, where they were working on the old Go version. He said, think of entries as your data model.
Right.
So your object types. So like if you were when they were building their blog, the entries were like a post was an entry, a tag was an entry. So the entries meaning entries in your like chain, data chain that you're zipping around, and everybody has to validate. So everybody needs to validate that everyone else is behaving correctly, and only if someone agrees with me, or only data that has been sent to me that validates according to my validating entry types are entries that I'll respect.
Right. Yeah, exactly. The thing that was most helpful for me, and so far anyway, was the idea that the entry types are the only types of things that your Holochain app is going to add to your local chain. Like it adds things of one of these types. There's no other types it can add. And I assume it's also what helps you understand, if you're reading off of somebody else's local chain to add it to yours, that's what helps you understand that data. You have to interpret it as one of these entry types. So
these are the things we expect from other people.
Right.
And
so
nothing else.
Right. Everything has to be in there if you want to use it, basically. Then this Genesis function is like a special function that my understanding of it right now is that it's the thing that sort of Holochain checks to make sure everything is like, it can start working, basically. Like, is this a valid Holochain thing?
A hash chain needs a starting point.
Right.
And it's really convenient sometimes to just put arbitrary data in the starting point, rather than having to, because there may be things you want in your starting point that you don't want to write validators for.
Yeah.
And so you just say the Genesis, the first thing is just presumed to be valid. And if everybody has the same Genesis function, they're going to start with the same Genesis data hash.
Yeah. So we'll see later. They talk more about the Genesis thing, but we'll see that a lot of the time it looks like Genesis is just returning a result in Rust, which is just either okay or an error, basically.
When you don't need anything specific in your Genesis, it's just like unit.
Yeah, so they're unit. Yeah, you can see they're just saying okay, and the okay doesn't even have any wrapped information in it.
Right.
It's just saying the result is fine, like a valid. It's just literally saying valid result.
Start with 0 bytes for your Genesis.
Right. Yep. Okay, cool. And then function declarations. So that's your Zome's going to have a bunch of functions in it.
Oh, I think I might be losing you.
Oh, yeah. Is it better? Oh, yeah, you're definitely frozen for me right now. You're looking up at the sky. Oh, you're back, maybe.
Yeah, I think I am. Was that me? I think it might have been me.
Well, kind of a two-way thing.
Yeah. That was us anyway.
Yeah. It was our connection. Yeah. Right, so we've got function declarations, functions, traits. Right. This is definitely also a Rust thing that I'm not super familiar with yet.
Yeah, I can talk about traits a little bit.
Cool.
So in Rust there are types, right? Types might be a struct, types might be an int, and sometimes you want to give. So for example, like numbers. There are some things you can do with all numbers and some things you can only do with some kinds of numbers. And so if you want to write a function like highest or sum, you want to be able to sum integer 8s and integer 16s and integer 32s, and you don't want to have to write sum 8 and sum 16 and sum 32. So you write sum on anything with the summable trait. And when you define int 8, in order to make int 8 summable, someone can implement the int 8 summable trait, which is a function of how to sum int 8s. And then maybe somebody wants to write a big, deep nested struct, and they want to be able to sum them together. they can write their own summable trait, which is just a function that takes two of them and gives you the sum of them, whatever that means in your case. So traits are a way to like treat many different implementations or many different types as sort of a higher order type. So reader is a big one. You want to be able to read from a file. You want to be able to read from a stream. You want to be able to read from a socket, read from a web connection. And you want to be able to write general code that just handles reading. And it just expects a stream of bytes from somewhere. And the reader, the reader trait, the readable implementation, and I don't know if it's readable in Rust or whatever, these names I'm making up on the spot, but those then, the read function just looks up the types read implementation and uses that to get its stream of bytes.
Cool. Yeah, that makes sense. Right, cool. And then the last thing, your code, which is funny because a lot of this stuff also is code, but yeah, code. Okay, cool.
So the rest of that might not be code. The rest of that might be referencing code, actually.
Right. Yeah.
Zome has the characters of Zome. A name needs description, config, Genesis.
This is not code. This is not code. This is not code. This might have a little bit of code in it.
It's either code or it references code.
Right.
It might just be the name of the Genesis function or the like.
Yeah. So you're right. I think because it's saying it's a callback, and the function is defined in the code
itself.
Yeah.
Right.
Right. And this is similar.
Function declarations are probably like.
These are all the functions that I want to.
Holochain function is called
accessible.
Write. It's called write in this module in the code. So yeah.
And then traits similar. Right. It's a set of declarations. Yep. Cool. Okay. So that makes sense. All right. Building in Rust. This define Zome macro.
Yep.
Oh, sounds like we're getting a little bit of echo.
Oh, are we getting echo from my mic and speakers?
A little bit, I think. Oh, yeah, a little bit. Here, I
can turn my volume down a little bit too.
I'll just turn up the threshold a little bit.
Okay.
On your noise gate. Should do it. Yeah, seems like it's good. Say something though.
Hey.
Yeah, okay, seems fine.
Cool.
All right, so this define. Oh, I got a little bit more. I mean, it's probably fine. Okay. So here's the define Zome macro. This is what it looks like if you do a really simple one. And as it's saying here, this is actually a whole Zome. The most minimalistic Zome.
Most basic Zome. Zome that does nothing.
Right, so it has entries. This is the function declarations, I assume.
Yep.
I don't know what the capabilities.
Yeah, capabilities wasn't in that list, was it?
It wasn't, yeah. We'll see later, I guess. Yeah, maybe. But you can see the other things in there. Perhaps that's just where the code goes. I don't know. It is a code block.
Yeah, maybe.
Right, and this is just reviewing the same stuff.
Yep.
Okay, and let's move on here.
Cool. Yep, let's move on.
Right, so this is starting to get interesting stuff. So app entry type definitions. An entry is a data element that an agent authors to their source chain. So this is what we were talking about earlier. Anything that your Holochain app is going to write to that agent's local chain, which is what propagates all the local chains, is what propagates the distributed chain, has to be one of these entry types. So this is a pretty important thing to think about when you're making an app, it sounds like.
Right.
Right, and then this is probably related to the Genesis thing, I would assume. The entry is backed by a chain header, which is the data element used for verification of the integrity of itself as well as the entry. But maybe not. Maybe that's something else.
Right. That is the same. Like, the only reason it's not called a blockchain is because we're not putting anything into blocks. We're not like creating blocks of entries. We're just chaining each entry off the previous one.
Right. And also, it would be it would be brand confusing, because while there are a bunch of similarities, there's some really big differences between Holochain and blockchain.
That's really unfortunate that cryptocurrencies are synonymous with blockchain, where blockchain is just sort of like an enabling technology. It's a data structure. And it's a phenomenal data structure, but it's not the whole thing.
Definitely not. Yeah. And we'll see how that evolves.
Yep.
But okay, so how do we define app entry types? Right, so you should think about what types of data the Zome is designed to handle: users, transactions, friendships, tasks. This is what we were talking about. You got to think about what kinds of data it's sort of like what is your database going to look like for your app? You know, what are the different tables you're going to need?
Yep.
Okay, broadly speaking, developer of Zome is designing the behavior and generic properties of data of that type. So you want to think about how the data is shared or not shared with peers.
Right.
Schema for entries of the type, so sort of the metadata for that, that type. Custom validation behavior for entries of the type. So what type of validation do you need? You know, do you even need validation?
Right.
Types of relationships that can exist between entry types. So this really sounds a lot like database.
Yeah.
You know, how would you think about a database?
Yeah, this is all the stuff except for the sort of what is shared and what is not. That's kind of the more. I mean, that's still in sort of centralized development too, but it's much more important here, I think.
Right. Yeah. These two, how is it shared or not shared, and how is it validated, which are pretty related, I think.
You can't initially trust the data coming in.
Right. And in a centralized application, this stuff is happening, but you basically don't think about it a lot of the time because you just assume everything is trustworthy.
Yep. And more often than you'd want to believe, it's not happening.
Right. It has data types have names, descriptions, and also a sharing property. This was covered, or something like it was covered in an earlier article, where it sounds like you could have custom options here, but what some starting ones they have are private and public, where private is, there was this section near the beginning where they're talking about...
Yeah, it stays on the author's device.
Landing a DApp, I think. They're talking about these different... Yeah, so they're talking about this stuff. Yeah. So you can have data that's public and it's shared on, out to the network. You can have data that's public, but it's only going to be on your network. And you can even have data that's private and local only, but still gets validated, which is really cool.
Yep.
So yes, a lot of options there. So primary options are private and public. Private means entries of this type will stay only on the device of the author, and can even, not even be shared with anybody else. Like it's only on your local chain. And public means entries of this type will be gossiped to other peers, sharing copies of the DNA. And gossiped is this is the mechanism by which the distributed hash table propagates, rather than like a blockchain where all the nodes have to be running and then they have to talk to each other every time they all want to add an entry to the a single block to the chain.
Blockchains use a gossip protocol too to get transactions moving through the network, but blockchains use a similar gossip protocol to get gossip the blocks around to all validate that somebody found one.
Right, that makes sense. I mean, it's kind of a fundamental. I'm definitely not an expert on this, but my impression is that this is basically the fundamental peer-to-peer thing.
Yes. Yeah.
This is how you take a network, which is in a lot of ways a liquid network where like nodes are going to pop in and pop out all the time. You don't know
no one's in charge
where they're going to be. You can't really have a plan about how you're going to share things because it's constantly changing. So you just need a system where like if you're online and they're online, you share to them because you have the opportunity to do it, and then
you just tell everybody what you were told.
Everybody does that. Yeah.
Everybody that you know about, you tell whatever you were told.
Yep. Luckily, luckily there are some ways to sort of make sure that the message is not telephoning, where it,
and making sure that it's
so it's not transforming as you go around the room,
Totally.
And like the first person said, I won the ice skating competition, and the last person thinks you said like elephants live on Mars or something.
Yep.
Humans are like pretty bad at this. Luckily, we have computers. Okay, so here's an example of an entry types section. So this would be all the entry types, and this is something that would be in the JSON configuration for a Zome. So I assume that's the. Yep. Here they're saying it's a .dna.json file. This looks like what would be maybe in the Zome.json file. I'm not sure if that's what they mean. But we'll probably find that out when we look at some sample apps.
Nested, so nested within, it says nested within the JSON file of a Zome.
Right. So that sounds like just the Zome.json file to me.
So that .dna.json, the dot in the front of the file name means that it'll be a hidden file. So this may be something that their compiler is keeping, sort of keeping and generating on our behalf.
Right. So maybe this is a file that Holochain just makes.
Yep.
But anyway, so this looks like this entry would contain all the entry types, and then here's one example. There is only one entry type in this particular one. It's called post. It's a blog post. It has public sharing, and I don't know what this is. Yeah. And I believe this is pseudo code. I believe it actually doesn't look like that exactly. I think it.
So it's the code that's the metadata that it'll probably generate from the entry.
Right.
Like we write something in Rust.
Right. So this is not what we would write. This is what it would generate.
It generates this.
Yeah. It would be nice if it was this easy, but I think it's a little more complicated than that. This is what it generates in the end. So that seems fairly clear. Now, how do we actually make something like this in our code? So here we've got importing the HDK crate, which lets us use the define Zome macro. So we define the Zome. Entries is where we're going to put this stuff. So that's very much like this.
Mm-hmm.
And here we've got our first like custom type. I assume this is part of the HDK library, probably. Crate, I should say.
Yeah, so that's a type that probably comes in with that use macro thing, or importing that crate. Yep.
So I think this is. Here we go. So
the
entry macro. You're gonna define the name post. You're gonna do the description. So far, so good. Sharing. Now, here's where it starts to get a little bit more complicated. So here we're using a specific piece of HDK. This type of import stuff is not, I don't totally understand how Rust does this yet.
Yeah, so in a lot of like in Python, for example, that would just be hdk.holochain.core_types.dna.entrytypes.sharing.
Right.
Rust has a specific a difference between associated names and like method names. So these are just like this double colon is like associated.
Right.
The
and
Holochain
so
core types that comes from the HDK crate, and the DNA that comes from the Holochain core types that comes from the HDK crate.
Yeah. So I think that it would do the same thing if you just wrote use HDK and then copied this entire thing here.
Yeah.
But that's just looks bad.
Shorten that name to just use sharing.
Yeah, and doing this lets you just directly call
And you
something from
could
sharing.
even probably
Add public at the end here, probably, right?
You could put : sharing at the end of the use statement and just use share or public. Sorry, you could do :
Yeah. And then just directly use public
instead of sharing public.
Right.
Yeah. This is I think public in that context ends up being more confusing. Like the sharing : public is nice context.
Right.
In the entry point. So, or in the entry macro. Yeah.
Right. So this is what we're actually putting as sharing in order to get this to mean the right thing. We don't just put, public string.
Public, right.
We're actually putting some real code in here, or referencing some real code in here.
And what that does is it lets Holochain change the format of their JSON file representation. Like if they want to capitalize it or whatever, they can do that without breaking old code. Because we're just referencing their type, and their type is defined as a certain thing, and they can change that definition without breaking our code.
Right, because this is just referencing something from HDK. So that changes, then our code will change too. Okay, so let's check out what this says actually. Sharing refers to whether entries of this type are right. We talked about that. The value must be referenced from an enum in the HDK. So that's what we're doing here, I think. Holochain currently supports the first two values in the enum, public and private.
Yep.
So in order to add more options here, you would need to add them to the HDK, I think, or make an equivalent.
If you wanted to add more options, you'd get involved in the Holochain project and work there.
So we probably won't be doing that. Although it's possible we would need something and then we'd end up contributing to the HDK. So enums are another thing that is an important part of Rust, which we'll probably talk about more later. Okay, native type. They say that it's interesting. Okay. So yeah, lots of dependencies here. The reason this has so many dependencies is because we are reading. This is a sort of a reading library, I think. Crate. This is So this is a Serde. I don't know how you're supposed to say this.
Yeah, I don't either.
I don't know if it's a different. It sort of looks like Spanish, but it could just be like a funny abbreviation of something too.
Yep.
I like Serde though. That sounds better than Surd to me.
Sure.
So this basically lets us read JSON. Sounds like.
Yeah, read and serialize and parse JSON.
Right, and whatnot.
So yeah, going from a Rust type to a JSON.
Right.
string.
So you can see 3 of these dependencies are that, and then here we've got one of them that's
core types derive.
Yeah, so that's not part of HDK. So this is a different Holochain thing. So maybe it'll talk about that a little bit. Right. They say over and over again how important these lines are. These like extra lines on top of the external calls.
From derive, serialize, deserialize. JSON. Yeah.
So this one, the macro use is what lets you use macros. This feature try from thing.
I'm not sure what that is.
It says here, it switches on a Rust feature that would otherwise be off, allowing attempted conversions between types. So normally Rust would not let you try to convert between types, and this is going to let you do that, which you need to do to parse the JSON.
Yeah, it turns off some of the safety features.
Right. Or it looks like it's maybe turning on a feature that turns off safety features or avoids them somehow or something like that.
Yeah.
Like it's saying, I want to use this try from feature.
Please.
Yeah. Okay. Additionally, the HDK offers built-in conversion functions from JSON strings to entry structs. This comes from the default JSON derive. Is that this, maybe?
Next line, derive. It's the last in the... Yeah.
Every struct as a native type reference should include all 4 derives. So that's
that. Yeah.
This. Right, and they do come from Holochain core types derive.
Yep.
Although they seem to say that that's from HDK, but this doesn't actually seem to be from HDK, so I'm not sure what that means, but I'm probably just missing something. Or it's possible that that's just wrong and it would be HDK :
Maybe part of the development kit. They may consider it philosophically part of the development kit, even if it's in a different module.
Yeah, in a different crate or whatnot. Yeah, that could totally be the case. Then there is the struct itself. This is the real type definition. So they're talking about this now. It is simply a list of property names, the keys, and the types of values expected, which should be set to one of the primitive types of the language. So this is just regular Rust, I think.
Yes.
This is just a regular struct in Rust, which is a way you can define custom types.
Yep.
So this would be if you're saying that some data is a post type, then you're saying that data is going to have inside it a field content, which is a string, and date created, which is also a string. And then you're gonna reference that as the native type in your entry macro in order to construct the, what do they call it? Validating entry type.
Right.
Okay, validation package. So here we've got another part of HDK called validation package definition. And this is another part of the entry macro.
Yep.
So
have you come across that syntax in Rust yet?
This double bar thing. Uh-oh. Busy?
I'm here. Hello.
Yep. Okay, cool.
Yeah, I mean that double bar thing.
I have seen it, but I don't know what it is yet.
So that's a function literal. So that's like the things in between the bars are the parameters, and the things in between the braces are the function body. So that's a function that takes no parameters and returns entry. Validation package definition entry.
Oh, so it's a way of just not having to write FN, basically.
Right, not having to define a name, not having to name it.
Right.
Not having to do FN that name and then this body and then reference it. It's just like an inline. This is a function that takes these arguments and.
Right. Okay. Which is useful for a function like this, where you're really just trying to return a value. So you don't really need to bother with defining inputs or outputs other than that.
Right.
Okay. So looking at the above code, there is a required import, right? That's the enum validation package definition. Yeah, it's a function that takes no arguments. That's what it's saying. It will be called as a callback by Holochain. The result should be a value from this enum. These values can be seen here. Look at that later. Most basic option is just entry, which means no extra metadata beyond the entry itself, which I'm not sure what other metadata you would.
It's got to match the form of this entry, right? So that means we have defined this entry to have these two fields of these two types. And if it has those two fields and those two fields are those two types, then it's valid. We could define some other validation, like the date field has to be of this format, of this specific date format, or it has to match this regex, or it can't start with a capital letter or something like that. And we could add that code in here, but often it's just like, as long as it's got the right fields and those fields are the right types, then it's valid.
Right, and it sounds like they've got probably here some other types of checks you can add in.
Okay, yeah, cool.
But by default, Holochain is going to use this as a way of basically adding the type checking in, but doing it on its end, sort of.
Yeah.
So that sort of makes sense.
Yeah.
Although we're not in a position to totally understand why that's necessary.
This is a lot of this is guesses.
Yeah.
Yeah.
But it sounds like that's what it's doing, and there's probably a good reason for it if it is.
Yep.
Okay, so more validation. This was the validation package. Now we're doing just validation data. This is the last required property. It has its own in-depth article, which is called, yeah, it's probably somewhere down here.
Yep.
It's a callback in order to confirm which action to take with the entry, depending on its validity. We called with two arguments, the first representing the struct of the entry itself, the second struct extra metadata that can be used for validation, including the validation package. The callback should return.
So can we? What was that sentence again? We will be called. Let's see. The first representing the struct of the entry, okay, and the second struct holding extra metadata. Hopefully, we'll learn about that extra metadata soon.
Right. Called with two arguments.
If it was requested.
The validation package, which is interesting. So you don't always have to request it, I guess.
I see. The validation package.
Second.
So wait. We may have skimmed the validation and misunderstood the validation package. Validation package definition. I see. So this is a function of how to get the validation package. This is how you get the validation package. And the default validation package. Right.
This doesn't actually validate anything. It
doesn't. No, it
gives
just generates
you the function
default validation package based on the entry.
Yeah,
right. We could add extra stuff in here if we wanted to. That would get passed to this validation method with the specific piece of data to validate.
Okay. Right. Yeah. So this isn't even. This is really just getting a function that you can use to generate a validation package for this entry if you want to.
Yes.
Which is an option here.
Yes.
Yeah, so this is taking, right, so it's taking the entry and then whatever validation you want to use for the entry, which can include the validation package, but also other things.
Right.
Other ways of validating it. And it should return a result, which is, I mean, that's what Rust is going to do a lot of the time. This okay is a result of this is a super simple version of it that's just saying it's going to be okay all the time no matter what happens, which is for sure not the point.
The result, right?
Yes. Yeah, it's definitely one of the cool things about Rust is the way it deals with it error. Makes things extra safe with these functions that kind of build in option where the result is kind of a fork in this cool way, like and result is one of those, and option is kind of the other one, and they're sort of versions of the same thing, but really common.
But there's two kinds of them, right? Like you can have an okay result or an error result, and it's always going to be one of those two things, and it always could be one of those two things. So when you're dealing with something that's returning a result, you have to handle both of those cases.
Yeah, it's cool because it basically strongly encourages you to do some sort of at least moderately smart error handling, like really built into the code.
It at least forces you to say, if it's an error, I don't care. You have to say that explicitly.
Right. Yeah. So pretty cool. Right. So this is for sure not the validation that you would want to do. Like, take these inputs and then just say it's okay no matter what is probably not a very useful validation. But it gets the idea that that's the type that it needs to return. Which a lot of the time you don't need to. I don't think you need to tell Rust, please return a result, because a lot of what it does just returns a result.
Maybe. Yeah, I think if the return type of your function is result, you have to wrap it in that okay or error.
Right, exactly. But you don't need to tell it, please return a result. Like the match function in Rust will give you results.
It'll infer that it's supposed to return a result, and if it's not a result, it'll complain at you. Yeah. It won't complain.
Right, if you haven't given it, the response, if it's okay or error, then it'll tell you you've done something wrong. Validity of an entry is therefore defined by the author of a Zome. Yeah, so you are telling the Zome how it's supposed to validate what it's doing, which is pretty interesting. First of all, data which doesn't conform to the schema defined by the native type will fail. So that's kind of built in, because this is actually that's not true if you don't tell this to use the validation package.
So
right?
What does it say? What does it say?
So first of all, data which doesn't conform to the schema defined by the native type will fail. I think that means if you do this, if you, in the validation, you input the validation package function and then you use it in the validation function, then it's going to make sure that the data always matches the native type.
That sentence to me sounds like validation of an entry is therefore defined by the author of a zone. First of all, data which doesn't conform to the schema defined by the native type will fail. So it sounds like no matter what, if it's not,
does sound like that.
If it doesn't match the schema, it will fail, and that's defined by you because you defined the schema. But you also have a chance to do further validation.
Right.
So this okay here is just saying I have no further validation to do.
Right. So maybe Holochain just does this.
Yeah.
So
yeah, I think it doesn't. It's not going to give you the option to accept things that aren't of your schema.
Right.
Which is, I think that's good. that makes
it does make sense, but it is slightly confusing to me because they are saying that you have the option of not including the validation package here.
Yeah.
I would have assumed it needed the validation package to do that.
Right.
So we're probably missing some information here, but I'm sure that there's some way with that all makes perfect sense, and we're just not quite aware of everything. This seems important. Let's read this paragraph. Note that only the entry author will call this function to validate the entry during its creation. So if you're running this Holochain app on your machine, you're going to validate your own data to put it on your own hash table. No one else is validating that during that data's adding to your own local chain.
Not when you're creating it, right?
Right, not when you're creating that data. But other peers will call this function to validate the entry when it is requested via the network that they hold a copy of it. So if the Gossip protocol is saying, hey, Jesse, take this data and put it on your hash table too, then your Holochain is going to validate it as well. It's not just going to assume that I've validated it correctly already.
Right. So it looks like you validate everything. Every peer validates data before they send it, but they don't validate it when they receive it. I think that's what that's saying.
They validate it when
it is requested via the network that they hold a copy of it. That's not a very clear sentence. Other peers will call this function to validate the entry.
Yeah, I'm assuming that means they're going to call their version of the function, not your version, which they should be the exact same, right?
It's the same because they have the same DNA.
They have the same DNA. So
they call it when it is requested via the network that they hold a copy of it. I don't understand that they hold a copy of it part of it.
I think that's just referring to the Gossip protocol.
Yeah.
That's like there are going to be situations where the protocol is saying this should be gossiped from this address to that address, and when that happens,
right,
the validation should happen.
Someone on the network is going to want a copy of that data to read it, to perform, if it's a post, they want to read the post, right?
Right.
So they're going to ask the network for that post, and then either the person who is in charge of holding that bit of the data on their part of the chain or on their part of the hash table, they then validate it on the way out when they're responding to that request, or they validate it on the way in. It's not totally clear.
Yeah, I think that the implication here is this validation only happens when that data needs to actually be added to someone else's local chain.
Sure. Yeah.
So if I'm just trying to read a blog post and there's nothing about that I need to add to my chain, I just want to request to look at the data, and it's not necessary for me to do that, then I don't need to validate it. Although you could still validate it, and probably makes sense to in a lot of cases. Just because Rust is a typed thing,
right? And that's how they get the data integrity without having to trust people on the network. You don't have to know who's out there. You don't have to trust who they are. You can verify that they're behaving correctly, whether they're mean and awful people or not.
And you can see why the DNA concept is at the heart of this, because that's what makes sure that your validation function is the same as their validation function. Yep. So if they've validated it and then you validated it, then you can be pretty confident that you did the same thing they did.
On those validation functions being pure, meaning that like
pure.
If the validation function like generates a random number and compares it to that, then it won't always validate the same way. So if the validation functions are impure, that assumption can be broken.
Yeah.
So
interesting.
It'd be pretty important that the validation functions are pure.
Yeah, that's not a concept I'm familiar with. So interesting. Okay, so here's just a summary here. So here's a finished entry macro. Name, description, sharing public. Native type is post. Where this is
a struct with
right. This is referring to a struct that we've defined elsewhere, and a validation package, which is this. It sounds like this is going to be the same in a lot of entries. It's just calling a generic validation package for an entry function. You could have other functions here, other metadata, but you also have a chance to add stuff here. So it sounds like this will be standard a lot of the time. And then the actual specific way that this type of entry is supposed to be validated, which will often use this validation package, but can also use other types of validation. And then it's going to return a result, presumably something that either says this is validated or it's not validated, basically. This can be embedded directly inside of the entries array of the defined Zome, like so. So here's defined Zome, here's entries, which is one of the requirements for defined Zome, and you're putting an entry macro as one of the entries in the entries. Whatever Rust calls this data type. I don't actually know.
Vector maybe? Array maybe?
Yeah, array or vector, I think. I'm not sure which one is the default.
It might be array, but I don't know.
Yeah, well, whatever. Yeah, I don't know if you would actually want to do this. You may want to define these elsewhere just for neatness.
My guess is that it's an array because you want it defined once and you don't want it to grow or shrink.
Right.
And arrays have arrays cannot change length in Rust.
Right, which is interesting.
Yeah.
Although it seems like every language just has its own somewhat arbitrary way of naming.
Name for the thing that's like a list that you can add and subtract.
They all have a number of different types of lists that act in slightly different ways.
Yep.
And that's fine. Right, so that's what that would look like. Right, so here they're saying if there's multiple, you probably want to... Oh, right, so this is actually interesting because you don't just take this out and put it up here and set a variable equal to it and then call the variable here. What they're saying is you should actually do it with a function. You should make a function that creates the post definition by calling this entry macro.
Yeah, that makes sense.
And then you're going to call the function in here.
That's nice.
Which makes sense because that's more of an equivalent of calling the macro.
It's also cleaner, and it's like when you're reading, you can tell that it's post without having to look at the name is post, entry name post. You can just say post definition. Great. We've got the post definition, we got this, that, the other.
Yep. And there you go. So here are some examples. API reference. What does that mean? That doesn't sound like an example in code.
Nope. The API reference might have some examples. I don't know.
I'd rather look at a real. Okay, great, cool. Well, you know what? If we want to look at a real one, let's look at one of these. I don't know which of these.
Tutorial is probably the best one.
Sure, let's check it out. I want to look at the README to see. This looks like an okay README. But let's see if we've got any of these have like a real nice looking README.
That one doesn't have a README at all.
Nope, which is not nice looking. One looks okay.
Here we go.
Maybe HoloVault. This is. Nope, that's nothing. Simple app. Simple app reading. I don't know. I don't know which one is better. Basic example using Holochain Rust. Builds under. Let's look at this one.
Yeah. Let's take a look. So it's a to-do app, which is nice.
Zomes.
Yeah, let's look at the Zomes since that's what we've been reading about.
Yeah. Although this is immediately confusing to me that the only thing in Zomes is a lists folder. Or wait, what?
So Zomes. So the way that the way that this is just how GitHub shows folders with nothing but another folder in it.
Right, but okay, I just haven't seen any mention of doing Zomes with a folder called lists.
List is the Zome name. So.
Oh, right, of course. Yeah. So it's got one Zome called lists.
And that Zome is called lists.
And here's a JSON file, which should just be a description. Yeah.
A lists app.
So awesome. And here we've got a Zome. It's got the build. This is pretty much the same in every Zome. It's just saying, here's the steps. Yeah, you're gonna say cargo build. You're gonna do it release. This is just one of the options that you want to do for cargo build that makes it. I think it just further optimizes the code and takes a little bit longer.
This is all default and automatic from.
Yeah, and then here it is being turned into WASM.
Yep.
And I'm not sure what this is, but it's probably like a documentation thing.
Put the artifact at this place, target/wasm32 unknown releases list.
Gotcha.
So that it's in a known place, and the rest of the Holochain toolchain can figure it out.
Right, and then let's check it out. This has one file in it. So here we can see this is a lot of the stuff that that we just saw. Although interestingly, not all of it. They've only got one Saturday. I think the example we saw had like 3 different Saturday grades. Yeah,
2 Saturdays and
this
type drive.
Yeah, this guy, which we do have in here. We got the main ones here.
Between 0.3 and 0.4 or 0.003.
Could be. This is 0.003 or 0.0.3. Here we've got a lot of. Okay, so here's an interesting. This is just a Rust thing again, but this looks like a useful way of doing use that lets you.
Oh, I see. Yeah.
All things without. This would have been annoying if they had to write out the entire HDK or the HDK Holochain hash string over and over again. You can nest these things to do it quicker. And here's our define zone macro, which is probably like the entire. Yeah. Okay. So now there's a little bit more. Right. So here we've got a lot of stuff. It does look like they just put the entries right.
The entry definition function.
Yeah. They only have 2 entries, so it seemed like. Not too bad to just put them in here. So we've got a list entry, no description, got that sharing public, native type list, which we'll probably see further down.
So importantly, if this is a to-do list app, this is a public to-do list app. Everybody can see all the lists.
Yep. So anybody can see what you've got on your to-do list.
If you make a list, people can see your list.
Yep. Right. It's interesting to just think of all the different types of sharing and validation you might want. Right. So this would be a kind where all the data is going to be validated and anybody can see it. So anybody can see anybody's to-do list and also be pretty confident that that's really their to-do list. You can also imagine an app where you don't want to share that stuff. You want everybody to be keeping their own private to-do list, but you maybe still want to make sure that that is really what they're doing. So
and that it's backed up by everybody else. So the one way to do that would be to keep this sharing public, and we may see that this is what's happening. Keep that sharing public, but encrypt your list. Right. So then the encrypted list, which only you can decrypt, is gossiped to everybody. So everybody's backing that list up for you, but you're the only one that can actually get to it. Everybody knows that you have a list. They just don't know what the list is.
Right. And everybody can confirm that that's really the list you have. They just can't read it.
Yes. Everybody confirmed that they have the correct list. They just can't confirm what it is.
And there's even kind of 2 different ways of doing that. One would be what you're saying, where you're sharing it publicly, but it's encrypted, and that will let you do things like share the key to that encryption with your team.
Yep.
So that now it's sort of like a team to-do list. Or you can do one where it's just encrypted with your private account, your agent key, and it's just the encryption is just the regular hash, and it's just hashing your data. No one else is ever going to be able to get at it unless they have access to your whole account. But everyone can still validate that that's really the data that you have.
Yeah, and you won't ever be able to encrypt your data by hashing it.
It's similar though, right? It functions similarly.
Hashing is like one-way encryption. So
Right.
encryption is like assumes that you can decrypt it. Hashing, that you cannot decrypt it. No one can.
Right. Yeah. But it functions similarly in that, like, if you want everyone to accept what you're doing,
algorithms and turn them into hash algorithms.
Right. Like it functions this similarly. This is kind of the coolness of like Merkle trees, right? Is that if I have 6 to-dos and then I hash them and then that gets gossiped out, and now I'm going back to work and I'm checking off some of my to-dos, I have to, and then I want to change that. I have to show that, that I actually validated that data on top of the previous data in order for the next hash that I want to propagate out to the network to be accepted by everybody.
Yeah.
So it functions similarly to, like, if I was decrypting the existing data and then changing it a little bit and then
I think that the only thing that I'm that I don't like there is decrypt means something very specific, and it means recover the plaintext.
Right. Yeah. Okay. Well,
so if you have the plaintext to begin with, you can validate that it's correct.
Right. Yeah. No, so I'm sure in a lot of important technical ways it's not functioning similarly. Yes. But in like a social way, it's functioning similarly. Like,
yes, you're right. Yes.
It's letting you continue to update your data in a way that everybody else can validate is really happening, but it's not being shared in any literal sense.
Right.
Okay, cool. So we've got the list thing, got validation package. This is just the standard thing that we saw. Looks like you can not include the brackets if you want.
Oh, sure. Yep. Looks like that's the shorthand
little thing. And then here's the validation thing. Interestingly, this is still using... so I guess this is just here they're just avoiding using fn or naming the function.
Yep.
But they are defining some inputs here, which are the type and then
the validation
CTX, which I don't know what that stands for,
probably
but then...
for context.
Okay. Context.
Yeah. So the context in which this list is right now is this validation data. So the context might include like the author of it, the time that it was authored. Some other stuff. Like maybe your app says people can only write to-dos before noon because afternoon is supposed to be execution time or whatever.
Right. So maybe, wait, let's go back for a second. This validation data thing. Yeah, so you can see that's what
it looks to me like there is an implicit automatic check that it matches the type signature.
Yeah, so my guess is that this validation data thing is expecting this.
It's the result of calling that function. Validation data, I think, is the result of calling the validation package function. So in this case, it's entry.
Well, but you haven't called this function.
We haven't, but Holochain will.
Okay, I guess right, sure.
These are callbacks that we're giving to Holochain, and they're going to call them for us.
Yeah, I guess I was thinking maybe it would be that this function actually takes this function as an input or something like that. And so when Holochain calls this,
I think validation package definition entry when called is validation data. I'm not
could
sure
be that's
that at all actually.
It's a similar idea.
The most confusing.
Yeah, the idea is that this confusion about whether or not it's optional.
Yeah.
For Holochain to validate that you're following your own type structure.
Yeah.
This does imply that it's optional somehow. But
I have a feeling
it doesn't look optional.
We're kind of getting ahead of ourselves. It has its own in-depth article. We'll get to it.
Yeah. This is not important for us to figure out. It's just tempting me with this confusion.
Yeah. Callbacks also are like a confusing brain wrapping your head around it kind of thing.
Yeah. But anyway, so it sort of looks like it's not optional to check your own type here, and I'm sure we'll find out more about that as we go. But here's the validation. So it's it's taking the type and also this validation data function, which probably is going to check that you're following your own type. And then this links thing, what is this again?
We haven't covered it.
Yeah, they haven't talked about it here. So,
but that's fine. We can.
Oh, you know what? This looks like a database thing, right? This reminds me of like a, list has many list items.
Yep.
That's what this sort of looks like.
It links to list item.
Right. Links to list item, tag items, similar validation stuff.
Same validation.
But it's taking some new stuff here.
Oh, that's interesting. Okay.
Makes sense, right? Like it wants to make sure that the list items actually belong to this list. So something like that.
Makes sense.
I assume is what that's doing. So anyway, okay. So then the other entry we've got in this app is a list item, which also has no description, same sharing, another native type, and the same type of validation. But this one does not link to anything.
Right, it doesn't link back. So this is a one-to-many relationship. My guess is that if it linked back, you
don't have
a many-to-many relationship. And an item could be in many lists, and a list could have many items.
Yeah, interesting that you don't have to define this link in both places, right? So.
Right, and that because the direction of the relationship matters. If a list can have many items, you want to link from the list to item.
And also, it probably depends on how you want to use the data, because I assume what this means is that if you get the data for a list, you're going to be able to look up all the list items in that list.
Yes.
But if you get a list item, you are not going to be able to look up which list that belongs to. At least not from the list item. You'd have to do it differently. You'd have to search through the list of lists and see which list has that list item. Something like that.
Right.
Maybe. That's sort of what it looks like to me anyway.
Sure.
Okay, Genesis. This is the example that we saw, so nothing fancy going on there. This is extra indented for some reason, which I don't know what it is.
Main is the name of the capability. Public is the access setting of the capability. Okay.
This is functions. That's where we are.
And we haven't gotten there yet.
Yeah. So.
But.
I think, no, we did. We sort of did. No, we didn't. They haven't talked.
Yeah, Genesis is next, and then Zome function, and then capability.
Yeah, okay, so let's keep reading.
Sure.
12:30. So, yeah, I mean, this makes sense for us to keep doing. It might be nice at some point to switch to seeing if we can do something with this app or something like that.
Sure.
Just for the sake of not reading tutorials for 3 straight hours or whatever.
Yeah. I do think let's get through
the Zomes chapter is quite
operations.
Long. Yeah.
Let's get through to operations and then go through the rest of that app, see if there's anything else we really feel like we don't understand well enough to try to run it. And then it looks like operations might be the next thing we want to do, trying to run it.
Yeah. And everyone watching the stream, which is currently 3 people, which I don't think includes us, actually.
Okay.
Although I could be wrong, because it was at 1 at some point. So if you have it open, then it's not.
Yeah, I had closed my video preview for a while. And I'll close it again.
Does that change
if it goes down? Yeah.
Yeah. Well, anyway, what I was going to say is that we have this working on my machine now, so we will not have to sit there looking at nothing.
Oh, right. That's right.
Yeah, and watching my computer struggle to try to install Holochain. So that should be beautiful. All right, so let's move on here. So Genesis. Yeah, I guess we should read a little bit about what this means. It seems to be pretty simple function, at least in their examples. But let's see what they're actually saying it's for. So every peer will be running instances of DNA. Yep, this is how peers join the network for a given DNA. There are. So you could think of it sort of how you you have to be the same species to breed or something weird like that.
Sure.
Is the metaphor. Yeah, let's not dive too deep into that because it definitely gets sketchy in more ways than one.
Yeah,
there are some.
The organism is designed to work with other organisms of that type, I think, is what the philosophy says, right? So if you're an organism of a different type, we can't validate things from you. We don't get the same cryptographic guarantees, like cryptographically guaranteeing that things are identical is possible. Cryptographically guaranteeing that things are compatible but different is not possible. Right. So we just say if it's exactly the same, you're in the same app, and everybody's just kind of running their part of it.
Right. So it's even though this is you can think of
what it is. It's like we're all cells in the same organism.
Yes,
and
that is what it's
the
like.
network is the organism, and not the app you're running is only one cell in this organism, and this is how you talk to other cells with the exact same DNA.
Right. Yeah, that's totally what it is. That's a much better metaphor. Yeah, cool. Okay, so there are some actions that a developer may wish to initiate on a new peer joining the network. For this reason, a hook into this moment of the lifecycle is implemented by Holochain. So Genesis is for when a new peer joins the network.
Right.
It also provides an opportunity to reject the user from joining if for some reason there's an issue with the way they are attempting to join.
Sure.
This is called Genesis. It's a callback that Holochain expects. So you're making the function, and then Holochain is going to call it. So you're not actually calling it. You're just giving it to Holochain. Every single Zome expects every single Zome. So every Zome is going to have this. And it's always going to be called Genesis. So it's sort of like a keyword in Holochain.
Yep. It's like a reserved word.
Yeah. If it does not exist, that will cause an error, and peers will not be able to launch an instance of the DNA. That makes perfect sense. It can reject. If it succeeds, the expected return value is just an integer representing that it succeeds, I guess. But if it fails, a string is expected to be passed explaining why. That sounds like totally Rust type behavior.
Yep.
When Holochain is attempting to launch an instance of a Zome, it will iterate through all the Zomes one by one, call Genesis within each, and they all need to succeed for it to launch.
So this sounds like a way to create a private network. You know how they say you can make it public but put it on a private network. So you could say only people who can run this Genesis, right? And the Genesis might check that their public key is in a list, and so only people on that list, the list that is in the Genesis function, can join. Otherwise, it's an error. And
that's the reason this is cool. That this is a function you design, because it sounds like probably by default, what Holochain is going to do if you define it this way is it's going to check that the new person trying to join is using the same DNA, and if they are, then great. You're good. That's all it does. But you can add anything else you want. So you can add a whitelist of addresses or whatever other thing. So pretty cool.
Right.
Only accept addresses that start with 0236.
Right. I mean, like
random group of people.
You could absolutely do that.
Yeah.
Or you could require somebody to do a lot of work before joining your network.
Interesting.
You could put a proof of work in Genesis and say you have to do 7 years of work and then you can join the network.
Right. You have to have validated this much stuff that the network is doing.
Or, like, I don't know, you could say you have to control these Bitcoin addresses before you can join this, or your address has to have paid 7 Bitcoin to this address before you can join the network.
Yeah. I mean, the possibilities are pretty wide open for this.
It's a general purpose programming language.
So cool. Very cool.
Pretty great.
Right. Okay. So how is Genesis used? It's used in defined Zome, which includes a closure called Genesis, which is past 0 arguments. So probably defined Zome maybe defines the rest of this function for you. Something like that. I don't know. Or does something with it beyond just this.
It defines the rest of the function. No, I think what they do is they validate. There's just two different functions. One that validates the DNA, and then one that also
this as a callback. Yeah.
Right. And again, this is a function literal, so it's got the 2 bars.
Yep. Yeah. So this is like one of the simplest possible functions you could have in Rust right here.
Yep. The simplest that returns a result.
Yeah. Also, a funny thing that I learned in Rust, I think, I could be remembering this wrong. If you ended this line with a semicolon, it wouldn't return anything, I think, maybe?
Right. Because so that turns it into a statement and not an expression.
Right. So expressions will return themselves, basically, but statements won't.
A function will return the last expression.
Yeah. Yeah.
Yep.
Yeah. Okay, cool. In the following 2 examples, nothing interesting will happen. They're just illustrating how to return success and how to return failure. More complex capabilities will be... Right. So here's an example. In this one, it's just going to return okay. In this one, it's just going to return an error. And you can define the string that you want the error to come with.
Yep.
You could put nothing in here, but that's not so useful.
But you have to pay 7 Bitcoin to this address to join.
Right. You haven't done whatever.
Yep.
Interesting that you have to toString this. I don't know why that is the case.
So I ran into this. Rust is that the string literal, the thing in the quotes, isn't a string. It's a slice. It's a stir slice.
Okay.
So that has a different type than standard string. So that toString just
right. Well, that makes sense then. Yeah. I don't think you would ever write Genesis like this, literally.
Nobody can join that network.
That wouldn't be so useful. But it does sound like you can write it like this, and that doesn't literally just let anyone join. They still have to have the same DNA. I'm assuming. It hasn't explicitly said that, but that is what it sounds like.
That is, I'm very confident about that one.
Yeah. Yeah. I think that's got to be what it would be, because they've said nothing about making apps where you don't have to make sure everyone's on the same DNA. And if that's true, why would they ask you to do that yourself? It doesn't make sense. So this is just an example.
It checks that you have the same DNA, and it checks that your Genesis works.
Right. So, and so with a really simple app, you have to just directly say, okay. If you were doing something in here, you would return a result, and then you would probably define, you would tell it, okay, and then also if it's an error, here's what you should say. Yep. But in this case, there's nothing to create an error, so you just directly do the okay. Okay, that makes sense. Let's move on. Functions. Okay, so now we're getting somewhere.
Now this is the meat.
Yeah, so this is really something that's just defined by what the Zome is supposed to do.
Right.
Lots of tools you can use. Holochain achieves this by exposing core functions to the WASM code of Zomes. That's a confusing sentence to me.
Yeah. Exposing a number of native capabilities to tell it begin.
I think that means like the HDK is going to let you use a bunch of functions from the HDK in these functions.
So what is it achieving by that? Okay.
Just being helpful.
By exposing a number of native capabilities of Holochain to Zome, and given access to a rich suite of tools that offer limitless ways they can be combined. The core function of WASM code.
Please let me edit you, copy. Limitless ways they can be combined. Right. So here's some examples. Read and write data. Transport messages directly between nodes of a network. Call functions in other Zomes. That's pretty cool. Even bridged DNA instances. That sounds interesting.
Yeah, that's. I have seen that come up, but only in sort of high level, future kind of discussions.
Right. Use cryptographic functions like signing and verification. That seems important.
Yep.
Glad it can let you do that. Emit signals containing data from a Zome to a UI, for example, which sounds like a pretty basic thing that most apps will want to do. Although not all, I'm sure there will be some sort of like middleware Zomes. How these functions work and how to use them will be covered throughout the rest of this chapter. Right. They can be in different programming languages, although right now we're really just going to be doing Rust.
Yep.
And they just mentioned that even the human readable version of Wasm is not highly readable, so they're not really going to show that. Okay, when Holochain loads a DNA file, it expects the presence of one or more Zomes, right? We know this. Here's a skeletal DNA JSON file. Now, this might be the thing that Holochain makes for you.
Yes.
So this is not what you'd actually be writing. This is what it's going to make.
Right.
And this is maybe what it would look like. So this is the name of the whole app, I think.
Yep.
And here's the Zomes.
And this app
test
has
zone.
Test zone called test zone.
It has
a public
traits.
function. Well, it doesn't
HC
have
public. That's a trait. So.
Oh yeah. That's okay.
So it's like, I think my assumption is this is like a category of functions, and these are like, you would say, put all the functions you want to be public here, and then maybe later you've got a function that like takes
private,
or maybe like you've got a function that takes a callback that has to be an HC public function,
some public
like
thing.
That.
Yep.
And then the code is whatever this is.
That's probably base64 compiled hello world or something.
Yeah, base64 encoded Wasm. So this would be presumably like, a bunch of stuff in most apps, and not like 6 characters. Yeah. Second is that even outside the Wasm code, right? So this is everything we just said. The nested function declarations property is an empty array. Noted. The second is that even outside of the Wasm code, Holochain expects a certain level of visibility into the functions contained within. Right, so that's sort of like, even though you're not actually
you need to tell us what you named.
Right, so like your functions are actually going to be in here. This is where all your code is.
Right.
Now it's compiled into Wasm. Right, but Holochain wants your Zome to also tell it the names of the functions. Yes. And not just give you a big pile of Wasm. And that's presumably so that another Zome can call a specific function from this Zome, things like that.
Without having to know Rust.
Without having to, get it out of this huge mess from scratch.
Yep.
And that makes a lot of sense and seems very useful. 2 reasons: to be able to reason about data inputs and outputs for those functions, to group those functions semantically. So that's traits, I think. Okay, here we go. Function declarations. So they're just saying, you're just going to declare all the Zomes functions here in an array.
Yeah.
Right. So this is an array, not a vector.
So this is JSON. So in JSON, it is definitely an array.
Right. Oh, right. You're right. This is the DNA JSON. Right. So here, this is just showing you what it's going to make the functions look like. Again, I think this is something that Holochain compiles, not something that you write by hand. So I don't think you would have to just make this. I think it's going to make it for you.
Those macros are doing.
Yeah.
Like the name that you put in the macro under name gets moved here.
Right. And so this is just the stuff you need, sort of the minimum stuff you need in order to call a function in Rust. You're going to need to know the name of the function, and you're going to need to know the names and types of
signature.
Yeah. I guess technically these names you could have made this arbitrary, but it's nicer to know what the names really are, and you definitely need to know the types.
Yep.
Although, sometimes you don't need to define the type in the input, but a lot of the time you will, and you certainly need the capability to do that.
In Rust, you'll always have to define the type. It will always have a well-defined type.
It seems like there are definitely some functions where you don't need to define the output type, though.
There are some times you don't need to define the output type in the Rust code because the Rust
because it infers it. Yeah, of course, Rust will always type everything and be strict about it, but there are situations where it will infer it for you, it seems like.
Right. And then this algorithm will also be able to infer it and will put the correct thing here.
Yeah, probably. Yeah. Okay, each function declaration is an object that includes the name. Yes, I think this makes sense. Traits. So this is traits specifically as a way to group functions, not types or other things.
Sure. Yep. Okay.
So this is sort of similar to what you were talking about with Haskell, or it reminds me of that.
Yeah, traits in Rust works that way too.
Right.
It's a lot of languages have things like this. They're called type classes in Haskell. They're called traits in Rust. They're called interfaces in Go and Java.
Okay. Primary use for this is, man, sometimes the jargon is real strong. Creating a composability space. It's like,
yeah,
maybe some people have connotation for that, but that sure would not have helped me understand what it means.
Yeah.
Where DNA creators can implement different DNAs to two emergent function interfaces and then compose with them in the conductor by matching on the function group names and signatures. Yeah. So that's a fancy way of saying it's useful sometimes to have a group of functions that you can put under the category Holochain public functions, basically, that helps you write code easier, because you might want to be able to grab any one of the public functions, and so then you need to define which
so
functions
in other words,
are public functions.
Right. Different people can create different public functions, and what it means to be a public function is that it has a certain interface.
Right. Functions grouped in this name will be automatically added to a public capability grant that happens at Genesis time, assuming like okay, you've succeeded the Genesis thing, you now have access to these public functions, that kind of thing.
Yes. Right.
Thus making them accessible to any caller. For more details, please see here. Here's an example. One interesting question I have here is, this is a file compiled by Holochain. So do you define these somewhere, or is it just checking, for example, all the functions that have sharing public and putting them in this trait for you?
It's not clear here. My guess is that's going to be in the capability section. My guess is yes.
Yeah. Yes. To which way?
That it figures it out for you.
Okay. Yeah. Yeah. I'm curious if it's going to also let you define custom traits, or if that's going to be something
it sounds like it will.
The HDK.
I think that's what they mean by the term emergent.
Okay. Yeah. Maybe. It's funny use of
emergent from people working on Holochain.
Okay. Yeah.
They will figure out good ways to do things, and they will say, "Oh, this is probably a good trait," and other people will agree and start writing under that trait name.
And that sounds like maybe you would be defining those traits then in the HDK, not like in your own code.
Yeah, I'm not sure. Yep.
Or at least this one sounds like maybe it is defined. Okay. Data interchange. In our support variety of languages, we wanted a simple language agnostic function specification format using Json. So that makes sense. So that if your Zome is in Rust and somebody's written a Zome that's in JavaScript, then they should still be able to call your function.
Yep.
If they have this information.
Yep.
This has two big implications. Holochain conductor implementations must handle JSONs here, right? So any HDK or
so the conductor is something different. They actually just renamed container to conductor.
Okay.
So conductor is a way, like the command line is a way to run it, and then the conductor is another way to run it. The conductor is the platform that takes all of the Zomes.
Yeah, it's sort of just like
checks that everybody's DNA is the same.
Yes, it's the Holochain implementation, basically, right?
Yeah,
it's the implementation of the basic protocol.
Yeah,
So any version of Holochain, which they're saying like you can make your own version of Holochain as long as it does the right things, then it's Holochain. One of the things it needs to be able to do is handle these JSON serialized functions.
Yes. Right.
And HTKs and Zomes must also help you.
Right.
Right. And Holochain mediates that by passing these strings.
Yep.
Cool. That makes sense. How Zome functions are called. They are called by received by Holochain from client requests. When function calls are being made, they will need to include a complete enough set of arguments to know the following: which zone, which function, which values should the function be called with.
Yep.
Makes sense. Before making the function call, Holochain will check the validity of the request. And I guess interesting to note, or good to note, that you don't need to know what types these values are supposed to be, because that's in here. They just have to be these types.
Right, and that's part of the validity. If you give me a value that doesn't conform to the type of the function, I know that that's invalid because I have the types in my
right.
DNA.
Before making the function call, Holochain will check. That's also an interesting issue with. I wonder if these have to be basic types.
Yeah, it seems like the types at this level are less expressive than the types can be in
yeah, because it does seem like it would be an issue if you were, if this was a Rust function and this type was like some type some struct you'd defined, and then someone was trying to call that from JavaScript. I'm not sure how that would be hard to figure out.
Impossible. I mean, it's translated, like the task list is actually an example of that, and it has been translated into type JSON.
Right. Okay. Right. Moving on. Before making the function call, it's going to check the validity of the request. Right. We were just talking about that. It's deemed valid. It will mount the WASM code for a Zome using its WASM interpreter, and then make a function call into that, giving it the arguments given to the request. When it receives a response, it will then pass the return value as a response to the request. This may sound complicated, but that's what's going on internally with an HTK and a conductor.
And the conductor handles that.
Right. So that's what the conductor is doing in order
to figures out what chunk of WASM to load up, what function in that chunk to call, what data to put into it, and then where to send the result.
And this is just kind of how WASM works, because nobody's writing programs directly in WASM.
Nope. Right.
So that's just how everything with WASM would work.
But sometimes you just write your whole program as one piece of WASM, load it up, and it runs and does everything for you. This conductor has stuff has a bunch of different WASM apps that it sort of loads up.
You're not just writing your own app, turning it into WASM, and then going, okay, go, because it has to be able to interact with all these other people's apps, and they might not be using the same stuff as you. But also, in all likelihood, you're going to be using multiple Zomes, and this whole thing about those Zomes being modular, it wants them to be modular. It wants to.
It needs to be. Yep.
Keep the it wants to compile at the last minute, sort of. Right. And then. Deal with it this way. So pretty cool stuff.
Very cool stuff.
Building in Rust, Zome functions. So here we go. Most complex version of defined Zome was this. It had no functions in it. We're going to add one. In order to add one, you need to declare this macro. Makes sense?
You need to define the Zome.
Yep, and then you need to write a function. Write the Rust code for the handler of that function. Okay, actually, that's not
right.
Not exactly the same.
Right. So they're making an explicit distinction between a quote-unquote holochain function, which is the name that the conductor knows about. Right? And the name that some other cell is going to ask me for that function call. And then then we write a handler for that function.
Interesting.
The conductor goes, where's the handler for this function? I call that handler.
Okay. So this is a big part of how it's doing this interpretation from so many different places to so many different other places. So you've got your defined Zome macro, you've got your functions array. Here's a function called send message. This is what it's going to be called. When it compiles the DNA file function, it's going to say send message. Right. Probably. And here you're defining the inputs, where you've got toAgent, and that's an address. So it does have custom types here.
Yes.
But it sounds like it might simplify those custom types in the final JSON.
Yep.
But you're still gonna, sounds like you need to still define, within your own code, you want to define the specific type.
Yep.
Which does make sense.
And those deriving statements will take that type and figure out what the JSON model of that is.
Yeah.
And we'll do all of that for you.
Yeah, and this one is really a holochain, some sort of global holochain
API
type.
result. So it's not, it's probably very similar to a result, but with some extra sauce.
Yeah. And then this handler thing, this is the function that you're going to actually write somewhere.
Yes.
In your code in Rust. And so when someone calls send message from your Zome, it's going to tell your Zome, hey, do send message. And your Zome's going to say, okay, what's the input? What's the output? Let's send those to this handler function.
Now I'm not clear on this. The Rust syntax here of the pipes, the vertical bars.
Right. Yeah. Why is it
before and after that
without any block?
Yeah.
I mean,
I wonder if that's just an empty function. It might be shorthand for an empty function.
That doesn't. Why?
In order to use Rust's type inference engine. I'm not totally clear on why that is the way it is, but I'm happy to just accept it.
I wonder if this. Yeah, I wonder if this is like a type validation function.
I don't know.
Like you put the inputs in here, and it's just going to return those inputs as long as they match these types, something like that. Right. Sort of what it looks like it might do. I'm assuming that if you have a blank function block, that it just returns the inputs, which may not be true, and maybe this does something else.
And the type checker will verify.
Right, and because you've got the types here, we'll also do type checks.
Yeah, I'm looking up what a function literal without a body is in Rust. But let's keep going on.
Yeah. Anyway, it's whatever. That's definitely some kind of Rust thing and not a holochain thing. So in this example, we've got the send message. It's got the name. It's got inputs. It's got outputs. It's got a handler. Step 2. Here is an example of a simplistic function. Centers. I also like how these are all written in this thing that like lets you run the code, and I'm pretty sure like they all do errors. Yeah.
Oh yeah.
Because like of course this is not a complete anything. That's just funny. Okay, so here this is like the handler that you would define for this. So this is a Rust function. So we've got a function called handle send message. It's going to take toAgent, which is an address type. That's some sort of customs type that we've made, and it's going to take a message, which is just a string.
Holochain address. So probably your public key or a hash of your public key.
Yeah, and actually, there's probably a type you can import as part of the HDK for that. Would be my guess.
Yes.
And it's going to output a Zome API result, which is also, I'm sure, a type that you can get from HDK or some part of Holochain thing. And here's what it's going to do. It's calling a function from the HDK crate called send. And that takes the toAgent thing, the message, and whatever this is, which I don't know what that is. 6,000 into. Is that a Rust thing? Do you know? 60,000, sorry.
Let me
Computer.
Arg.
I'm afraid I can't do that, Jesse.
Sorry, everybody. I think I need to close some of these. There's something that's taken up a lot of. But here we are. I'm back with you. Can you hear me?
I can hear you. Yeah.
Okay, good. I'll just stay here.
I think it's really okay.
So what was the thing you were?
I was wondering about this 60,000 that has .into.
Yeah, I've seen .into around. I'm not totally sure what that.
Yeah, we can look that up really quick, maybe.
Yeah.
This looks like what it is. conversion that consumes self may or may not be expensive. The reciprocal of from. Okay.
Reciprocal of from. So it might be like type conversion. Like if you do dot into, it's like dot into like. The type that you're inferring should be here.
Yeah.
That's my guess. So I'm a 60% on that one.
Yeah, so I don't know. I wonder what this is doing. So it's the HTTK send takes some kind of numeric input, which is not the address. It's like, I don't know, 60,000 somethings. Not sure what that is. But whatever, we don't need to worry about it right now.
What is it? What is that showing?
What is what showing?
Yeah, here's an example of simplistic function.
This is the handle send message. It's a handler function.
Okay, right. So handle send message.
Which is basically just calling this HTTK method called send.
So send, it takes the address, it takes the message to send, and it takes
this weird.
Probably a timeout.
Yeah, sure. That makes sense. Yeah.
That's my guess.
Yeah, no, that totally makes sense.
You might want it in milliseconds, and so
that maybe this just turns into it into the type that this function is expecting that to be, if possible.
The type that the type system infers should be there.
Right, which would still fail if it can't convert this into that type.
It'll just fail, right?
Yeah, so that's pretty cool if that's what that does.
Yep.
Okay, so that makes sense. Notice right away how the arguments match perfectly with the inputs. Yes, we did notice that. Yep. And the outputs, of course.
And
the name of the function, handle send message, is this. That's definitely has to match exactly, so that makes sense. Within the function, it's using this HTTK function, right, which we could go here to check out, which is the 0.4 version. The available functions, their purpose, how to use them. Okay. Handle message simply forwards the result of this. So yeah, it's really just a wrapper for this other function,
right?
Which is, it makes sense.
And it chooses a timeout for you, or if that's a timeout.
Yeah, you might ask, like, why not just put HTTK send here? Which you could probably do.
Here would be because you don't want to worry about whatever that 60,000 is.
Right. You don't want to worry about that. And also, I think it's a lot cleaner to have a clear name like this and a naming convention.
Yeah.
Otherwise,
I guess also
you'd have
you
all
want to
sorts of
expose
crazy
send
stuff.
as a Zome method, right? I don't think you can have a conductor just go to anything in the HTTK directly.
Probably not. Yeah. Yeah, that's probably true. It would have to. Yeah, that's probably right. Okay, cool. That makes sense. No, I clicked the arrow again accidentally. Right down here. Right, so here are the two steps combined. So this is just what we were just looking at. In the define Zome, you're going to want to put, say that you're including the send message function, define it in the metadata that Holochain needs about it, including which function it's actually supposed to call within your Zome, which is this handle send message function, which matches all the types from that. So that makes a lot of sense. Adding traits. Oh, okay. Okay.
Authoring. That looks like a custom trait. Cool.
Create post, update post. That's got to be custom. Or no, I guess it could be.
No, that's custom. I mean, posts are app specific.
Yeah, but this is also including a app specific thing. This might be let's see what it says. Additionally, it names an authoring trait. Yeah, I don't know. Yeah, maybe that's just. Yeah, it looks like you can just name whatever you want. I mean, but it does look like you can just name. You can just name your own traits here.
Yep, totally.
Yeah. So yeah, it does look like this is just totally custom. That it's not creating the HC public trait for you by looking at the sharing field for all your functions. That it's just putting whatever you say to put in there. At least that's what this looks like.
Perhaps. Yeah. Yep.
Okay, let's move on. we're on capabilities now.
It is. So let's read what was underneath there actually, because it says something about the reserve name. So HC public is a reserve name.
Okay, interesting.
So
HC public is reserved, but authoring is not.
Public capability grant at Genesis to the read post function.
So we're about to read about capabilities, so we might have better understanding about this after that.
The name authoring trait create post. Additionally, it names an authoring trait.
Right. So it sounds like you're right that this is reserved in some way, and this is not. But this is still saying which functions should be included in this trait.
Yes. Okay. We don't have to define HC public. We will have to define authoring.
Right. Although I sort of thought that defining it just meant making the trait and saying which functions should be in it.
Maybe it gives us the ability to create capabilities and assign them to that trait.
Right. Or essentially sort of like meta types. So it's like the things in authoring
this
have to have these qualities.
We'll understand more when we see more like real world working things.
I think so, yeah.
Just like something to be aware of right now.
Okay, capabilities. Modified version of the capabilities security model. Okay, I'm curious what that links to. Capability-based security is a concept in the design of secure computing.
There's also object capabilities.
A capability, known in some systems as a key, is a communicable, unforgeable token of authority. That sure sounds familiar. It refers to a value that references an object along with an associated set of access rights. A user program on a capability-based operating system must use a capability to access an object.
Yeah.
Okay.
So this is a little bit like Google Docs sharing link. So anybody with the link can see it and edit.
Right. Yeah.
The link has a big, unforgeable, unguessable block in it. Right. And it's going over HTTPS, so nobody can see it, and you have to know that block in order to be able to use it. So capability security is about knowing the location, and the location is secret and unguessable.
Right. Okay, so Holochain DNA instances will grant revocable cryptographic capability tokens, which are shared as access credentials. Nice. So this is the way that the DNA. This is the actual mechanism that the network uses to let a new peer in. It sounds like.
Yeah.
Appropriate access credentials must be used to access functions in private data. This enables us to use a single security pattern for connecting end-user UIs, calls across zones within a DNA, bridging calls between different DNAs, which we really have not covered yet. That may be a still developing feature, we don't know. And providing selective users of a DNA the ability to query private entries. Right, so this is the thing of like, if you wanted to have sort of a private database, so to speak, within a certain app, or you wanted to have an app that allowed users to do that, to like make their own private data that they could share with just the people they want to share it with. This would be the mechanism. Each capability grant gets recorded as a private entry on the grantor's chain and are validated against every Zome function. Chain. Okay, that makes sense. As a version, capabilities are not fully implemented. In this version, you must declare all functions as public using the special.
Okay.
So are they saying there's just only use public functions, or are they saying
the only capability that has been implemented is the trivial capability, which lets anybody do anything?
Right. Okay.
Which we're calling HC public.
Fair enough. Functions in that trait will be added to the public capability grant, which gets auto-committed during Genesis, and thus, because other capability grants aren't yet available, all Zome functions must be made public. Okay, yeah. All right, well, so lots of cool stuff, lots cool stuff available now. But cool, that's fine. We will probably only be needing to do public stuff a lot at the beginning anyway.
Yeah, probably.
Although, for sure, there will be a lot of really good use cases for the not public stuff. So hopefully that's not too far away. This article has nothing in it.
Alrighty.
And this is where we wanted to stop anyway. Oh, is that what the E means? Oh, the E might just mean there's nothing here yet.
Oh, empty. Yep.
Yeah. Yeah, there you go. Okay, so we read most of this section anyway.
Okay.
Oh,
so
man.
I could use
a break. You want to take a break? Okay, let's do it. Yeah, I want to get some food. Take a whiz.
Yeah. Come back in 5 minutes and maybe look through the rest of that to-do app.
Yeah, and if we feel up to it, we can try cloning it and doing something with it if there is such a thing for us to do.
Yep, trying to run it, figure out what the operations are like, and then maybe if that goes really quick and easy, trying to start writing something of our own. I think the idea that each running copy of the DNA is actually a cell in a larger application is the mental switch.
Yeah.
Other than everybody running their own application for themselves, everybody's running a version of the server for everybody.
Right. Yeah, that's a great metaphor because it's the fact that the cells have basically all the same DNA is what makes the system work. That's why a bunch of cells can die and a bunch of new cells can replace them, and there's still total continuity.
And it's the app is emergent from all of the cells running.
Right. The learned behavior of the entire app, or the organism, which in our case would be like the distributed hash table, right? It's like this, your hand probably has some different antibodies and stuff than your foot because it had different germs and stuff. But if they need to share that information because those germs are now in your foot, like they know how to do that. Like that's one of the things your cells could do. Anyway, cool stuff. Okay, we'll be back in 5 minutes to do all that stuff.
Back at 12:20.
12:20, perfect.
Yep, cool.
Okay, yeah. Here we go.
I think we're good. Yep.
We're back.
Hello. We both got a little bit of food.
It looks like you can't hear my chewing on the mic, so we should.
Good. Good.
Cool.
Thank you, Noisegate.
Noise. That makes it sound like some kind of a public scandal, you know? Noisegate.
Yeah.
Like there were kids making noise in the neighborhood.
Yeah.
The saga of Noisegate continues.
Uptown Noisegate.
Yeah.
All right. So yeah, it looks like we got to a point where we might be a little bit more reliant on like just the code documentation and API documentation and stuff. But I think I've got a pretty good sense of the structure of what Holochain's responsibility is, and then what the hApp's responsibility is. And at least where to look for information about, like, the Zome API result, like that's somewhere we can go look at its generated documentation and stuff. So I think we are ready to look at that to-do app a little more.
Yeah. So let's just pick up where we left off. So we were looking at this this library file lib. I don't know. Rust people, what do you call this file? You call it library? Feels awkward, but that's what it stands for.
Lib. Lib.rust.
Yeah, lib is fine, I guess. It's a little political sounding, but
there's often a standard lib.
Well, the worst was somebody made, you know, like when someone hosts a group muse, they give it a title, right? And I guess there's some neighborhood in San Francisco or New York or something called No Libs. And so they made a group muse called No Libs Group Muse. And I was like, oh, is this some kind of weird alt-right thing? Like, what's going on here? And it was just like a neighborhood name, I guess, but it just sounded so much like that. Yeah, No Libs. I can't remember if it was 2 words. Like, you know, it's probably like North something, right?
Oh, yeah.
Yeah, it's Philadelphia. Northern Liberties. It's called
Northern
No Libs.
Liberties, No Libs.
Yeah.
It's like Soma.
Right.
In San Francisco.
Yeah, which is pretty appropriate for San Francisco.
Yeah.
Right. Okay. So we're looking at our lib file. We're looking at our define zone macro. We talked about the entries. We talked about Genesis. And now here we've got functions. Not sure why this has like an extra indent. Seems like this should just be here. There's some reason for that. It probably doesn't matter, but
where's the extra indent? Oh, I see. Yeah,
just functions itself. Yeah, I think it's just this line. I think the rest of it is where it should.
Yeah, I think you're right.
Expect it to be.
Main should be indented from functions.
Yeah, I think whatever. It's probably just a mistake, or maybe there's some other reason. Whatever. Main is the name of the capability. So this is not what we were looking at here. Zone function. What we were looking at here looked like this.
Yeah.
Oh, okay. So let's look at this again here. Yeah, so this is quite different. Main public. Well. They're calling it main public inside of functions. Here, inside of functions. Oh, and also functions here is a dictionary or whatever Rust calls these things.
It's a block.
Yeah.
That's interesting. Okay. I wonder if that's...
Oh, it is just a... This might be a new thing or an old thing. Like this might be the older version and this is newer.
It might be an alternate syntax.
Yeah, could also be.
Oh, we do see in there the things we recognize with the...
Right, so this stuff is what we expect. I mean, maybe all this... Yeah, maybe it is just an alternate syntax because this is just calling this function, and this function just, I guess, returns this. Maybe.
That's what it is, yeah. Yeah, they're setting functions to the result of a function call. So main is defined somewhere. Let's look at main. Let's try to find main.
Yeah.
And see what it's doing.
No, this is it.
That's it.
No, I don't think there's any other code to look at.
Nope. Okay.
It's nothing else. Yeah. There's nothing.
That might be a sort of like a bit of fanciness from someone that knows the API, like knows what's being imported a little better than us.
Yeah. I mean, this doesn't. Yeah, I don't know. I don't know what's going on here.
Yeah.
I mean, that looks like a function that has to be defined somewhere.
Yeah.
Although there is a space here. So maybe main is some kind of keyword in the API.
I doubt it.
Yeah, it doesn't seem like it would be.
No, I think.
But anyway, if this does work, for sure what it's doing is just outputting this.
Yeah. Yeah, I think we can trust that that's what's happening.
Yeah. And so here you can see we've got 3 functions: create list, add item, and get list. Those sound like great functions for a to-do list.
Yep.
Create list takes a list and outputs a Zome API result. I have a feeling we're probably going to see that a lot as the output. It's got a handler called handle create list. Add item takes a list item and a list address. So not the list itself, but a list address, which makes sense because that's the part of that you actually want, probably.
Okay. Yep.
Although what's notable here is that
my guess is that that's the address of the list on the distributed hash table.
Right. Yeah, I think that that's probably what it is.
Mm-hmm.
One thing that's interesting here is, of course, when you're adding an item, you need to know which list to add it to. Right. But with the way that types are defined, list is the only thing linked to list item. List items are not linked back to list. So I wonder if that's
kind of links are often implemented on the side that doesn't seem like the right.
Right.
Right. I mean, like if you want many list items per list, that means one way to implement that is to on the list item create a single field that is the list this belongs to, and it's not a list of lists, a list of addresses. It's a single address.
Right.
You can implement that on the item, or you can implement it on the list where.
Yeah. Or you can do both.
List is a list of.
Yeah, like when I think of Ruby, you would just do both. It would always be both. But there's no reason there's no reason in theory it has to be both. And this does make sense when you think about what this function probably does. It probably finds this list and then adds this to the list.
And this means it doesn't have to change the list structure at all. It doesn't have to append anything to the list.
Doesn't it? But it did have to append to the list.
Not the list object.
Well, it has to link somehow to the list. Well, whatever. We'll see what it does.
Right. The way it links is that it references it. Yeah, we'll see.
Yeah. Anyway, handle add item and get list. My guess would be this function's probably called in here. And this takes a list address. Yeah. Happening. Puts out a Zome API result. Oh, but look, these actually have things inside them.
Right.
So this is some kind of meta type within a type thing.
Those are generic types. So, for example, array or vector might be a generic type. A vector can have,
like you're saying, Zome API result is acting as a generic.
You can have a vector of strings or a vector of integers, or you can have a Zone API result of addresses or of address. So it's a result, and the result contains an address.
Right.
And this one contains a get list result or response, which is defined somewhere.
Yeah, I assume that's somewhere down there. Notable that these types don't need to be entries, as even though they're used by the program, you're never going to be storing a list response on the actual chain. on anyone's actual chain.
Oh, I see. Yeah, you don't necessarily.
Right. You're going to be storing a list, but you're not going to be storing the result of this function ever.
Right.
Okay, so those all make sense. Okay, here we've got this line, which this is still a Rust thing that I don't totally understand. You have to call this before.
Derive is a cool thing. I think those are all traits. So serialize is a trait, deserialize is a trait, debug is a trait, default JSON is a trait.
Okay, that makes sense.
So this is a way to derive trait implementations automatically based on by introspecting the list, right? So since it's a string, it's got a name, you could easily serialize that by just making it a JSON object that looks very similar, right?
So wait, what is that? What does this derive actually mean? Like, I see this is a struct.
It doesn't Haskell. In Haskell, it automatically generates type class implementations for your data type.
Okay.
So this is most likely automatically generating traits for your data type. So it's serializable, and you don't really care how it's serializable. You just want to be able to get it into a serialized thing to send over the wire somehow, and you want to be able to get it back at the end. So
would it be fair to say that you could think of, if these are indeed traits, would it be fair to say you could think of traits as almost like imported libraries for your struct?
Yeah. So anything.
So by doing this, you don't have to rewrite that.
You have a wire protocol
every time.
Mm-hmm. So say you have a wire protocol that knows how to send data over the internet. It doesn't care what the data is; it just needs a string of bits. And you can implement that to say anything that you tell me how to serialize, I can send over the wire. So if I don't have to know all of the types and structs and things that you're gonna eventually write to use with me, I just need you to implement the serialized trait in order for me to be able to handle it. And then I can take anything that's a serialize and I can send it over the wire.
Right.
And I can also give you back, if you give me serialize and deserialize, I can accept these things over the wire and give it back to you in your struct format.
Cool. That actually seems really useful in both directions.
Yes. Very, very useful.
Cool. Yeah. Okay. So we can see that all these structs are being given the same for
that thing. And these are clearly the traits that the conductor needs. The conductor is written handling serialize, deserialize, debug, and default JSON things.
Seems like that. Interesting that, just syntactically, it's interesting to me that this line goes here and not inside the struct.
Sure. Yep.
Just kind of interesting. Okay, so we've got a list. These are just our entry types and such.
Yep.
Actually, interesting. Yeah. So list, right, which just has name.
Yep.
Although we'll also have an address on the chain.
Yeah, because I think all entries get addresses automatically.
Right. You don't need to put that here because the fact that it's an entry here, it means it's gonna get that when it becomes an entry.
There's other things. I think an author. I think a timestamp. I think there's a number of things that every entry will get.
Right, and it gets those things as an entry. Those fields are not part of its type itself.
Right.
It's like the Holochain entry contains this list, but it also has other stuff.
Yep.
So this is an entry. This is also an entry. It has two qualities: a string and a Boolean called completed. It's a to-do list, so you can check things off.
Yep.
And then we've got a type here called getListResponse, or I guess we should call them structs. GetListResponse. This one is not an entry, but it is a type that's used by the code, and it's got a name and a vector of items, which is a vector of list items, which is a struct. So that all makes sense. So here we've got some functions. These are our handler functions, it looks like. So these correspond to these functions. Should have handle get list, handle add item, and handle create list. Here's handle create list, which takes a list. It's going to return an address API result.
Mm-hmm.
And it's declaring called list entry, which is of type. Oh, okay, interesting. So here's where it's making the proper entry type.
Yeah, so this is a function call.
Yeah, entry app. So this is an app entry. There's presumably other types of entries, which doesn't look like we're using here.
Yeah, this is new to me.
Yeah.
Because we didn't define this, did we?
No, I don't think so. I think this is something we should look at the API documentation for.
Yeah, let's look up entry app.
How do I get back to where I want to go? Just here. API reference is probably what we want here. Now, we do want to know which version of API this is using. What is the best? Just here. Oh, actually, I think I know. This is using 0.0.3. Oh, is he still there?
Yep, I'm still here.
Okay, cool. Right, so this is using
003.
I don't know if we want developer preview. I guess that's just the name of the release.
Yes.
Back to here. What we're looking for is the entry. Probably not type sensitive, but
and we'll have to see which entry they mean by looking at the import statement.
Yeah. This one it looks like.
Yeah, so that is HDK Holochain.
That's this one, I think,
entry,
right?
Entry.
Oh, HDK Holochain core types.
If I'm understanding that import statement correctly. Yeah, there we go.
One of these.
It's the bottom one, the second one.
That one. Okay. Yeah, right. So here's app. So there's actually a lot of variants here.
Okay, cool.
App is the one that we're gonna look at here.
Yep.
There's also DNA, agent ID, deletion, blockchain, eat your heart out.
Yeah. Well, deletion just means treat this like it was deleted.
Right. Yeah. Oh, I mean, that's what we like. That's not uncommon with centralized applications too.
Nope. But often I like to call it archive.
I do appreciate that starting to become the word on the user end too, because it definitely is a little disturbing when you think you're deleting something and it's just absolutely not getting deleted on the database.
You're removing it from the
you're just removing it from your own visibility. You're actively making the app less transparent for yourself every time you do it.
Yeah.
Okay, link this. I don't know. This I'm sure has something to do with linking of entries, which we saw some mention of, and then this stuff, chain header, something to do with Genesis, maybe something to do with starting a chain or validating that it's
or maintaining the chain as the chain
as the chain grows so that you can check it from the beginning every time.
Yep.
Chain migrate, I don't know. Who knows? App token, I don't know what these are. Oh, this is capability. Capabilities. Right.
Cool.
That all makes sense. Let's check. This one out.
So this is probably like your chain can have a bunch of different entries. Some of them, all of them except for app, are defined by Holochain and managed by the conductor. But the application entries are the app entries, right? So the entries that your app is making go in this app entry type.
Right. Yeah, it sounds like it's probably doing a lot of this stuff that you just don't need to worry about.
Right.
And that mostly you're going to be doing this.
Right.
And yeah, I don't know if we need to look at it much more than this.
I think it's making an
pretty
application
clear.
entry.
Yeah, and it's going to take a type and a value.
Yep.
Yeah, worth noting that this type is one of these types.
Yes.
Not a Rust struct type.
Right.
although they're obviously related.
Right. So where are we there?
We're down here.
Yeah. So this list.into that okay. So that does make me think.
Yes, it's the thing we were looking at before.
Infer the
Yeah. So that's pretty cool, actually. I mean, that makes it really convenient to do this.
That does.
So this is the type. It's just saying the type is list.
Right.
Turn that into if you can, turn that into the type that the function's looking for. Yeah. And then the value is list.
Right.
Is this list?
Right.
This list. The list into this function.
Right.
And then this is obviously an important part of the function.
Yes.
HTK commit entry.
And that looks like it's got an extra indent there too.
And we're referencing. So this is not a thing I totally understand. Maybe you can. I get that this means it's referencing this list entry. I've never done a language where you would do anything other than just put list entry.
This is about how data is.
Uh-oh, I think I just lost you. We'll wait patiently for Jesse to return from internet purgatory. Ooh. He's in a deep. Oh my gosh. He got swallowed up by a series of tubes. Should be back shortly, I think.
I'm back.
There he is. Oh, I didn't have to give you permission that time. That's interesting.
Yeah, that's cool.
Cool. Okay. So you were saying about the
I wasn't I?
The reference variable referencing.
Reference, right? The ampersand. So
yeah,
it has to do with how data is laid out in memory, and whether or not you, in Rust specifically, it's whether or not you own the data or you're someone where it is, and someone who knows where it is has different capabilities with it than someone who owns it. So it's like the address, the and list entry is the address that the list entry is stored at.
Right. So it's sort of like saying this function has only permissions of a sort of like read-only permissions.
Yes, and you can give out mutable references, but not if there are any other open references. So you can give out any number of read-only references like this, because it's reading does not interfere with other readers. But if there's any open read references, like if there's any read references like in any live scope, then you cannot give out a mutable reference, because that mutable reference might mutate something that somebody like in the middle of somebody else's reading it, and they could get bad data. So this is a safety thing in Rust. It's a convenience thing in other languages. But so basically they're letting commit entry read what's in the list entry, right, but not do anything else.
Yeah, this would default be unmutable unless you put mute in front of it.
I think and mute. I don't know. I forget.
Oh, maybe it's and mute list entry.
Yep.
Yeah, that's probably. So would it be fair to say that a rule of thumb there is like, if you're not going to be changing the variable, you should pass it a reference?
Yes. Yep.
Okay, that makes sense. And it seems like a subtler distinction whether or not you should, if you are going to be changing it, whether or not you should pass it the actual variable versus a mutable reference.
So if you are going to be, so it's more like
Although this is just immutable anyway because they haven't declared it to be.
Right. But even list entry and list entry is a different type than list entry is. So the commit entry has to declare in its type signature whether or not it wants a reference, a thing, or a mutable reference.
We should actually check this out. Probably.
Yeah.
Ooh, which one?
I think that's the case. I might be wrong there.
It looks like it's just directly calling it through HTK here.
Oh yeah, it's just HTTK commit entry. Yep.
But that isn't the thing.
Interesting.
This might be 0.0.4. This guide.
Sure. Let's look at that. I think that.
This looks like the right one. API.
Yeah, it takes a reference to an entry.
A reference to an entry. Interesting. Okay, so
what it's
Rust
saying is I'm not gonna change this. And you can know that commit entry, you don't have to like go research the code, right? Like you don't have to go dig into, you don't have to audit that code. You know that it can't change the entry.
Yeah. But what if you did list entry.into? I wonder if that would do that for you. Probably not.
Maybe.
Be interesting.
Yeah, I don't know. It could be smart enough to do that.
Right. So it seems like Rust can kind of treat the reference thing as almost like a trait where it can tell if what you're passing is a reference regardless of what it is, of what else it is.
Yeah, and they do that by making reference a different type than the thing. And so the type checker says, oh, I have a thing. I don't have an and thing.
Oh.
I'm looking for an and thing and I don't have it.
Okay, and here's what this presumably does. Attempts to commit an entry to your local source chain. Yeah, so this is a super important part of Holochain, right?
Yeah.
This is what makes it potentially infinitely scalable in a way that any global consensus blockchain for every modification of the chain having to go into a block and then go out to everybody and propagate that way. This is what makes Holochain so much potentially faster, is that this is just attempting to commit it to your local source chain. You're validating it in your own thing, which you're using the DNA for, and then if you try to gossip that entry to someone else, they're going to verify it with their DNA, and there's that same security is going to be there, but there's none of the road blocking. Of a blockchain.
That data will make its way through the network eventually, but that's separate from you moving on and doing whatever you want to do.
Right. So it's sort of like, you could think of it as, this system doesn't really care less about getting an accurate global consensus, but it cares way less about when that consensus happens.
Yes, it is eventual consensus.
Yeah. So, cool stuff.
Yeah, very cool. It's more like we kick anybody who's claiming we were wrong out.
Right. Yeah.
Like anybody can claim whatever they want, but we can validate it. And if they say something we know to be wrong, we'll stop listening to them.
Yeah, and also, like, you're free to do more stuff. Like, you can commit this. You don't have to wait until everybody else accepts that before you do another thing, unless we specify that, right? Unless we specify that we need to wait.
Yep.
Yeah, so it's pretty cool. I mean, it's not actually that crazy or technical when you think about it this way, it's hard to get into this stuff for people that aren't into it, but it isn't as crazy as it seems at first. When you hear about like computer security protocol, blah 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 blah, it's not that obscure. Like this is way easier than quantum physics, guys.
Yeah, it's not rocket surgery.
Yeah. Right. Okay. So there you go. This is the line that tries to commit this to your local chain,
yes.
Which isn't free. It's not like if you're on your computer and you try to like save a .doc file, your computer just only cares if you have write permissions for that file. Mm-hmm. It's not doing very much validation. So this would still be validating a decent amount for you, but it's going to be super fast, even if you have a huge distributed hash. So that's pretty cool. Okay, so then I imagine the rest of these functions are going to be similar. Here's the handle add item. Here's the entry for that. It's doing the same stuff. Then it's making, so this is also, okay, interesting.
So it's adding the item and then it's linking the entries.
And this is a special Rust thing.
Yeah.
That I believe means...
if this fails,
return some kind of error. Yeah.
That might just be like, I think that's like if this fails panic, but that like let equals.
Yeah, this is a way of getting out of like the tip. There is like a really common problem, which is you do this and then this is null.
Right.
And your whole program crashes.
Right. Something like that.
And so this is saying
stuff that when we're better at Rust, we'll be more familiar with.
Right, and this is saying if that's possible, then like the program won't even compile or something like that.
Maybe.
Or whatever, something like that.
Yeah.
Anyway, it's a special Rust thing. Like this question mark actually represents like a pretty sophisticated. Yeah, pretty sophisticated. It's not just like a simple, like, is it true thing.
Yeah.
Yeah. But anyway, it's still basically just declaring a variable, just doing it in a special safe way. Yep. So it's declaring this, which is another one of these commits, which is interesting. So can
we look at the API again and see what command it returns?
It returns a zone. Right. So it's returning the address in the hash table. I think probably right. So it's trying to put the entry into your local source chain, and if it succeeds, then it's going to return the address of that entry in your local source chain.
Right.
That makes perfect sense.
If there's an error, it's going to return a none or a nil or something.
Right. It probably says down here.
Well, right.
Oh no, this is just an example.
Zome API results is an enum that's either an OK or a.
Yeah, it's
an error.
Possible that they have some intelligent error messages for this type. Right. Probably they do.
But I think that question mark ignores any error messages and just says...
Yeah, look, here, the result is either true or the Zome API error, which has a
bunch of things.
Yeah. Right. Which is cool Rust error handling stuff. Right, okay, so that's returning the address in the local chain.
Right.
Here we've got a new thing, link entries.
Yep.
Let's check this one out. Yeah, so I think these are all... Maybe this is something that changed in the new version where it's not just HTK : link entries, it's API.
I wonder if we're importing HTK API.
I don't...
Confused.
Oh, yeah, actually, sometimes it does work that way, and that's one of the things that's confusing about the way that these work. Like, I think in the Rust book, are you frozen again? Nuts. Okay, I'm gonna keep talking. He's back. Thank goodness. Yeah, I was just saying that I noticed in the Rust book sometimes these behave in strange ways, where you call something that's like a bunch of layers down by going HDK and then the last layer somehow, or something like that, where it seems to work differently depending on the cargo. Cargo? Is that no crate?
Yeah, that's Rust stuff to learn. We'll pick it up though.
Right. So link entries. What does this do? It takes an into string.
Interesting. But that's not even taking. So those are angle brackets.
Ah.
I don't know that syntax. Let's look at the function call again. Link entries.
HK link entries reference to the list address, item address, which we just made here, and then just this
items. Yeah, that's
like
weird type inference stuff.
3. Right. This is doing something. This is doing something to this. Oh, you know what it's doing? It's doing the into string thing. So you don't have to. You don't have to string.
Yeah, you know what? Yeah. It might be saying you can call this as long as S is an into string.
Yeah. I think it's saying like that we're gonna always call into string on S.
Right. So S, it's not specifying S as a specific type. It's saying anything with the trait into string can be here. Yeah. So this is like generically anything that can be turned into a string we can handle.
Interesting. Cool. Okay. Yeah. So we've got the base. Okay. Base. Why is it called base?
Don't know, but the list is the base.
Oh, I see. Okay. So this is an API call to create the link.
Yes.
So this is
it links the base to the target.
Right. So the base has the this is interesting actually. So it's not. I sort of would have expected it to do this for us because of this somehow.
Yeah.
But it seems like we're just manually doing it.
We're saying this is linkable to this.
Yeah, and here we are actually telling it to make the link.
Yep.
So this is the base. This is the thing that's... So these are like the two things that are getting linked, right? One of them's called the base. One of them's called the target. That's probably somewhat arbitrary. I don't know if that... Well, no, it's not arbitrary. Yeah, because the items... The list has items, right? So the base is connected to the target, not the other way around.
Right.
And then items
the connection is called items.
Yeah, that's basically the column you're adding it into. Tag. That's the tag.
Yeah.
Which it sounds like
this is not quite a tabular.
Right. I'm sure it's not, but that's the it's like
that's the idea. Yeah.
Right. You've got a list. Things belong to the list. And you want to put those things into groups somehow.
Yep.
And the tag is the name of the group.
Yep.
Yeah. It's not tabular in the sense that like I'm sure that the link entries. The items in the list don't need an ID, a sequential ID, because they already have an address. They already each have a unique address. So you don't need them to be.
The address is inferred from the data, I'm sure.
Right. So. And the addresses aren't going to be just like a counting up. It's not going to be 1, 2, 3, 4, 5. They're going to
be a hash. It's going to
crazy hashes that are just in a random order. They're just random hashes. Yep. So, interesting. Okay.
So items, I wonder if items, if that items needs to be in the to field. Can we go back and look at the to?
The to field?
No, in the UI, yeah, when they said link to this.
Oh, up here?
Yeah.
Yeah, because yes, it does here. Tag
item. So you do have to specify the tag for this link, and then
that makes sense.
Okay. Yep.
Yeah, so I imagine there's some kind of validation that's going to happen somewhere, right? This has its own. This link has its own validation. Right. Yeah. So.
Look, you know why?
Yeah. Right here.
Because this is part of the. They have to get all of this in the DNA, right?
Right. Yeah.
So they have to get the fact that you have a thing called list items and you have a tag called items.
Right, because it has to verify like, am I allowed to make this link?
Yeah.
And in order to do that, it needs to know these things for the link and also what to call it.
Make the link, you have to say.
Yeah, because you're calling,
that is
link this target to this base and tag it with items.
Yep.
And then it needs to go, okay, you're trying to do that. Let me validate that you're allowed to link that type to this type in that way.
Yep.
That kind of thing.
Yep.
Cool. Okay, so that makes sense.
Cool.
And then so then it's just returning a result. Okay. With inside it the item address.
With the address of the item. Yep.
Yeah. So I think this is also a really common Rust thing.
Yes.
In maybe some other languages, you would have just returned item address, but with Rust, you can return OK, because then it can also not return OK.
In Go, this function would return two things. It would return a result and an error. It would return item adder and a nil error, or it would return a nil item adder and a string error.
And so what this is doing,
have to handle both of those. You'd have to accept both of those.
Right. What this is doing is saying, if we get all the way to here, we're going to return OK with the item address.
Yep.
And if anything else happens, we're going to return, something else, like an error from here or from here. And if whatever is calling this function gets gets something besides an OK, then that's going to be an error because this is a result, that's how it works.
That's what the question mark does. I'm pretty sure this is not coming back to me. I'm pretty sure the question mark says, if this, since the pattern of trying a bunch of things, and if any of them error, just return that error.
Right.
If commit entry fails, we stop right there. We return
the error, and that's why you don't need to do any. You only need to return
because the function
okay here, right? Like if there was an error, because if you get to this line, then it is okay.
Right. Yes.
Then you didn't have that kind of error.
Because link entries didn't. If link entries fails, we will have committed the entry but not been able to link them, so this will return as an error.
Right.
Whatever error link entries have.
Right, which will tell you, the whole function will and tell you whether it's this error or this error. That's pretty cool, right? Like,
very nice.
We've got like pretty smart error handling here with basically no code that looks like it's error handling.
But
pretty cool.
Code that, when you know what it does, is easy to identify.
Right, it is error handling. It's just there's no messy like if error return string blah blah blah. There's none of that. Yeah. It's just this question mark.
Right.
Cool.
That is very cool. I like that.
Yeah. Okay. Cool. So that makes sense. That's how the linking thing works, which makes total sense.
Yep.
And then next function, handle
get
list. Right. So this is going to take a list address and it's going to return Zome API result get list response.
Yep. Which is the list name and all of its items.
Here we've got a nice thing here. So this must be one of the things we're getting from HDK.
Get as type.
I'm just gonna. What did I do? Get as type. Oh, it's.
Hold on. Someone is ringing our buzzer very, very aggressively. I'm gonna be right back.
Okay, it's probably your whatever the carpet thing. Okay, well I'm gonna keep looking at this. So get as type is actually defined here. So this is a work in progress thing. Anybody watching me right now? Yes, somebody is. Right, okay, so Jesse will be right back. But it looks like what's going on here is that right now they've defined get as type in this helper function category here, even though here they're actually calling it. They're just calling it here, but they're saying this is probably going to be part of HDK in the future. So in the future, this would be something that you're importing here. But let's see what it does.
I'm back. We're all good.
Okay, cool. I was just telling the stream that it looks like what they've done here is just they've just defined get as type, but there's a note that says this will probably be in HDK in the future.
Yeah, that makes sense.
So they're just directly calling it. What it's doing here so this has got another one of those fancy type things. So one of the things this takes. Oh, actually, this is interesting. So this is affecting
that is a try from app entry value.
This is affecting the result. not the
result
inputs.
of R. So you see that the capital R references. So the type here is address is a function. The type is a function from address hash string to Zome API type of R. And
Wait,
R
that's
is
the whole
anything that is a try from app entry.
Wait. The type is a function? I don't see how the type is a function.
The arrow.
I thought that just meant that's just how you indicate this is the result, I thought.
Oh, yes, of course.
So
so it takes a
the last time we saw this syntax, it was affecting one of the inputs. But here it looks like it's actually affecting the results. So that's a little bit confusing to me, but
so this will
so it's going to apply this to the R, or like it's only going to allow results that do that or something like that.
Right. You can only infer results. You can only get as types that have this try from app entry value implemented for them.
Yeah. So I don't totally understand that, and why you wouldn't just have the result be Zome API result app entry value. I'm sure there's a reason.
Value is not what you want to get. You want to get as some other type. This is a trait. Try from app entry value is.
Do you know what try from means?
Nope.
Maybe it means not app entry value.
So I think it's try to interpret this as some value.
Right, but why not just have the result be Zome API result app entry value then?
Because app entry value is a trait, not a type. We are defining the types that are the app entry values.
I see.
And okay. We want to get to them, but in order to do that, there has to be this thing implemented for them. That's what I think. I mean, I'm less confident about all of that, but something like that.
Yeah, that does make some sense. Okay, so get as type. This is a weird function. It's called get as type, but it just takes an address.
Right. So the address
not a type.
The data is all addressed so that it can be sort of evenly distributed around the distributed hash table.
Yeah.
So all pieces of data are just bytes that have addresses. And so when we ask for data, we're asking someone in the hash table to give us some bytes. And then we want to turn those bytes into some type. We want to interpret those bytes as a type.
Right. It just doesn't seem like... I just would have expected this function to take an address and the type it's trying to get.
Oh, sure.
But it's not doing that. But let's see what it actually is doing. Get result, get entry, add a reference of this address, and it's got this error handling again. Okay, so that's how you get we're getting whatever's at that address.
Right.
Which we know we can get because everything's public.
Yeah.
Well, I mean, I guess it could not exist, right?
Right, exactly.
And then we're saying the entry. Okay, what is going on here? Is get results, and then we're calling okay. Oh, this is another Rust thing.
Okay, or yeah.
So it's
either.
I think this is what. Well, actually, I don't know.
Yeah, I thought that's what the question mark did, and they might be doubling up on that.
Could be, yeah.
Sure, but
or maybe this is checking for some more specific thing that it wants to look for. I don't know.
Yeah.
Maybe for some reason this doesn't check for this specific issue.
Yeah.
Or something. Whatever. Okay, that seems like something that we would understand with a little more Rust experience.
Yep.
But anyway, so this is also checking for some kind of for an error, basically.
Mm-hmm.
We've also transferred the data into now this new variable entry.
Oh, you know what? Zome result might have some different kind of error handling, and the question mark might still return a Zome API error. If there's some other kind of error, it'll return that. But if it's a Zome API error, it might not. The question mark might not understand that.
Right, because this is supposed to return a Zome API result, probably.
Yes.
And if it doesn't return that, maybe this question mark doesn't do what it's supposed to do.
If it's a result error,
the more general error is a Zome API error.
Yeah.
Just a general any error with you.
So, right. So if it's an internal Zome API error, we have no entry at this address.
Right. And then it looks like this still, if it's yet another kind of error, this will also return that.
Right.
Okay, it was something like that anyway.
Lots of different error handling situations.
Yeah. And then cool, we've got our first match here, which is from everything I've seen, it's super common thing in Rust.
For this match thing.
Yeah, this match thing is really cool. So we're matching entry, which is this thing that we just made. And we're matching it to basically what match does. It says, okay, put a value here, and then we're going to have a block, and then we're going to compare that value to each these things. So this one, and then a block, and then this one, and the underscore means anything.
Yep.
So what this is essentially doing is saying, if this is this, do this. If not, do this.
If it's of type entry app with anything in the first value and an entry value in the second value, a thing named entry value in the second value, we're going to do this with entry value.
Right. Okay, so yeah,
if
so
it's
that's
any other
crazy.
type.
Yeah.
It's an error, Zome API error, internal.
Right, so what this is doing is like this entry is the data that we grabbed from the chain, from our local chain or from somebody else's local chain.
From the hash table.
From the hash table.
Yep.
At a specific address. And then this is taking the entry value. Wait, what? Is this checking for a type?
Yes, it's type. It's matching on type.
How do you know
and it
that?
can match on some more stuff, but yeah, it's matching on type.
How do you know that it's matching on type and not just? It looks to me like it would just be matching everything. The specific thing.
Because I think that's what match does.
Oh, match only matches a type? I thought it matched everything.
It has a pretty substantial match system, but yeah, the basic thing is it's matching on type. So you do like match entry, okay, do this, error, do that is the sort of basic.
Right. So this is a function call for an app entry. Right?
Not sure. No, I don't think in that context it is. I think that's destructuring. So if the type, if entry is an entry app.
But this is
that's an enum.
I mean, you could call this. We called this function earlier, right here, entry app.
That might have instantiated a type. I'm not sure. That might just be like the types constructor.
Right. I mean, yeah, maybe that's sort of a kind of a function.
And in that context, yeah, in the match context, it does that destructuring though.
Right. Maybe what this is doing here is saying
match on values too, for sure.
Right. Like what this does is it's saying, is the type of this the type that this constructs?
Right. So I think what we're doing here is matching on enums. So we can match on values.
Yeah.
Or we can match on enums.
Well, but I don't think this is the resulting thing. This is what we got off of chain, right? So I think this would match the result.
But entry app is an enum. If we go into the
I know, but I don't think this is an enum. Or it's not this. At least it's not the same one as this.
I think it is. Yeah, I think it's an app entry.
Wait, so you're saying, like, in order to, like, what we're doing here is constructing something.
Yes.
And you're saying we're constructing that enum. Yes? No?
One second, I have to handle something here.
Okay. We'll be right back, folks.
Is this still live streaming?
Yes, we are. Oh. But we're on a quick break because Bessie had to go to
You're on a break. Go say hi in a break.
And we're back.
Mm-hmm.
Also, the dog is here now.
Had to find a hammer for the.
Oh.
Pull a nail out of the floor or something to get the.
He's just hanging out. You can't see him unless you look at the stream. Unless you look at the stream. Look at the stream to see my dog.
Oh yeah. Hi.
Okay. He's just kind of standing half on the thing, half off. Right. So what I was asking was, when we do this, are you saying that's creating an enum?
It's creating an instance, or it's creating a value of that type. And the type is an enum, so the type can be any one of 5 or 6 different types.
Right, so this thing itself is the type, or the result of this is the type? Or is that not even the right way of looking at it?
Yeah, I think that's not quite the right way to put it. The type is like, integer. That's like saying, is integer of 1 the type, or is 1 the type? Right, 1 is an integer.
Oh, wait a second. Let's look at this entry app thing.
It is of type. Yeah.
Oh, right. No, there's so many of these. Which one was it again? This, I think.
Yeah. So entry is the type, and the variance.
Right. Okay. Yes. I was confusing this with with this.
Yes.
Yeah. So this is just making a type.
The value can be this, that, or the other. And in this case, the value is an app.
Right. So this is
matching on the fact that the value is an app.
What's weird to me about this is this thing. That's not declared anywhere.
So that's destructuring. So that's saying inside this app, there's anything. I don't care what it is.
Yeah.
In the first position. But in the second position, I want to name whatever's their entry value. Because I'm
okay.
Value in the result.
This is where it's being declared, and it's
so it's being destructured and it's binding the name to that.
Okay, yeah. So this is checking if this is an entry app.
Yep.
Then using these values of it.
Yeah.
And we're going to do this. We're going to go R.
If we can match this destructuring phrase to entry, then we're going to destructure it into that and use the names.
Okay, wow. So this is crazy.
Yeah.
So R is referencing the results type.
Yes.
And so we're going try to make this result type from the entry value.
Yes.
To owned, whatever that is.
Right. Yeah, so toOwned is part of that
toOwned.
like ownership thing. Like we're gonna try to take ownership of this value.
Is that? But so that's just a Rust thing.
That's a Rust thing, yeah.
Oh, that's the thing that's like we want to be able to write.
Yeah, and I think that might copy it. So like that gives us
make a copy of it,
a copy that we own,
that we can actually,
that we can do whatever.
we can mutate.
Yep.
Right. Okay. So it's saying if this is entry app,
yep,
what we really want to access is this second input.
Yes.
The second value in the entry app.
Yes.
And what we're going to try to do is try to create R, which is just app entry value. I don't know. Anyway, we're going to try to create this type, which I still don't.
Which is
any type of the that has the trait app entry value.
But
okay.
So wherever get as type is used, the app inference engine will know what type is supposed to be here.
Yeah.
Right. And so what we're going to do is we're going to do a try from, and try from depends on what type is supposed to be here.
Right. So
and try from needs an implementation. So assuming for any type that has that implementation.
Oh, you froze again. Internet struggles today. Oh, back. He's back.
I think we're back. My internet is just like flaky as crap today.
Yeah, it is. Right. So we're taking this. We're trying to make a type that has this trait, something like that, out of the entry value.
Yep.
So we're making a copy of the entry value that we can mess with.
Yep.
Which I assume we need to own it in order to try to make it into this type.
Yes.
Or something like that.
Yes, probably.
And then we're map error.
Map error. Yeah. So it looks like if we get an error, return this instead.
Right.
The error, like in there, is like the error. We have the underscore. We're like, we don't care what the error is. Map error takes a function and passes any errors into it.
Yeah.
And so we're like ignoring the error that got passed into it and saying, actually, it's this error.
Right. Okay. Yeah.
And so this whole a match is an expression, right?
Yes.
So this whole expression is going to be the result of that r.try from.
Yeah. If this matches that,
right,
then it's going to try to do this and return.
Right.
It's going to try to return this.
Right.
And what this is going to try to return is either.
None of these are actually returning yet. These are evaluating too. So there's no function calls that are returning anything. This match expression will evaluate to whatever this block evaluates to.
Yes. That. Right. Sorry, that's a better way of saying it. Yeah. So this is an expression, and it's trying to evaluate to something.
Yeah.
And because it's an expression, the function's going to try to return
it's
it.
An expression, and it's at the end, so the function will return this r. Dot try from if it manages to. Otherwise, it's going to return one of these errors.
Right. If entry does not match this enum, and if it's anything else, then we're going to return a result, and the result's going to be error, Zome API error internal. Get links did not return an app entry.
Yep.
Oh, so this is specific to this Zome, I think. This error.
Yes, get links.
I don't think this is what they would put in the HTTP version of this function.
Yeah. Probably.
It depends. Maybe this function is only useful for links. I don't know. That seems unlikely to me, but could be. Yeah. Right. So here we are with this thing again. Right, this is the end. So we're almost there. So we're declaring this unmutable list. We're trying to get as type. Oh, and then this is maybe
so this. See how we have the angle brackets here? We have to actually specify the type of R in our call.
Yeah, that's maybe replacing.
So now that R has to be a try from.
That's replacing this. Yeah.
Yes.
So this is sort of a default, I think.
Yeah.
And
like
what we're doing,
we're going to provide something here, and it has to.
We're putting in list. Yeah. Right. Yes, that's exactly what it is. So this try from is trying from this.
Yes.
Yeah. So it's not trying from this stuff. It's not like changing this. It's this R is just going to be this R. Yeah. But that's actually an input. That's sort of like a special type of input into the function.
It's an input of that type. It can't be anything other than one of those things.
Right. So this is a try from for the input, and it's saying I'm going to try to take what you put as an input here, but it's only going to work if it has this trait, or if it's of this type. If it's of this type. That's which list is an entry value. Right, and that probably grabs entry values from your app specifically, maybe. It might just look at the list of entries you've provided. Or it might just be like a sort of a meta type and make sure that it follows certain directions, whatever. Right, so it's saying, let's get as type list. Mm-hmm. And here's what we want to try to get as type. Yep. The list address and a clone of it, which seems a lot like toOwned, but it's different.
Oh yeah. Not sure what that's about.
Yeah, I imagine it's something like this. Something about.
Yeah, it's a Rusty thing.
Yeah, you need this to be a certain kind of variable. The easiest way to get that kind is to do this clone thing, probably, but I don't know why. And then we got a question mark. So if this messes up, then this handle list thing is going to return that error. Probably is how we think that works right now. Yeah. Doesn't mess up, then now we've got list as a list, which makes sense. Yep. So this function does exactly what we expected it to, which is try to grab this as this type. Right. And now we're trying to grab the list items.
And so this is actually probably where the deserialize trait that we have inferred on all of these things comes into play.
So explain. I don't know what deserialize.
So in order to deserialize something, we take just a raw string of bits that we get off the wire and turn those back into our Rust type.
Okay. Why is that called deserialize?
Because it's the opposite of serialize.
Okay. Serializes
takes a struct or a type and puts it into a serial format for sending over the wire.
Okay. Well, okay. Sure. Right. Okay. So HTTK get links. So I don't think we've looked at this one yet, right?
I don't think so.
I mean, I think we can guess what this is going to do. Yes, it does. But let's check it out anyway.
Yep.
I'm sure that's it. Yeah. Okay. Oh, did we? We did look at this. No, we didn't. But it's similar. It's similar to the like create link or whatever that was called. Link entries. It's similar to link. It's the other end of link.
Right.
So we're doing this thing again. So whatever you put in as S, it's going to try to turn that into a string, or at least check if it can be turned into a string. And you're going to put in the reference to an address. And
the tag. So you put in the base and the type of links you want in that base. Tag. So I want the list items.
And it's going to return a vector with the default return results.
Cool.
So then, interesting. So this also is doing the question mark thing. This is another cool thing about the question mark. You can just continue to chain functions after the question mark. Don't know what this is.
So that dot addresses links. So links are going to be like, okay, here's all of the links out of this list, this to-do list. Man, to-do lists are hard to talk through when you're also trying to talk through the programming concepts of like lists.
Right. Yeah.
But so you've got your list, and you're wanting to get all the items that are linked from that list. And
so you think this is just getting the addresses on the hash of those items? Yes. But this is just a plain old function. There's no way there's a Rust function to do that, is there?
No. That's a plain old method, and that's probably on the links.
You think? Oh, okay. That's just a method on whatever this is returning, which it doesn't really tell you. Yeah, default return result. Oh, here we go. Zome API result, get links result.
Right.
Right. So let's,
so
function
it's
addresses self.
Addresses.
Yeah. Right here.
And that gives a vector, an address to a vector of addresses. Or a reference. Maybe reference is the thing.
And then you can also make
a new get links result. Which is what we probably won't ever use that.
That's
the thing that we've just called uses that internally.
Yeah. Here we are. Okay, right. So right, we've got all the hash addresses from this. Yep. Now we're making an iter. This is just a Rust thing. In order to do an iteration like map, you just have to turn it into an iterator. Mapping, and we're taking each address, and we're doing the get as type thing, and we're looking for list items this time, because these should be list items. We're making, and we're checking with this toOwned thing. Yep. Although actually, look, here we did it with clone, and here we did it with toOwned.
Yeah, that's interesting.
That's too subtle for us right now, but they're definitely doing something sort of similar. Right. So now we've got at this point in the function chain, we've got a vector. I don't know, a vector or an array.
What app does is it replaces it. It creates a new vector.
Yeah, a new vector.
Having run this function on everything in the previous vector.
Right. So with the same number of entries, probably, or at least that function run on every single entry, and then the result attempted to put into a new vector, and then with that,
the result into the new vector, and it's either an okay or it's an error.
Right. And now with that, we're filtering out. Why is that not just filter? Filter map. Because I'm pretty sure filter is a function. Maybe it's not anymore, or maybe, well, whatever. So we're filtering all the okay results. So we're getting rid of the errors, essentially, is what that does. So that there's, our vector is not like okay, error, error, or whatever.
Right.
And then we're collecting that, and this is how you get out of an iterator, basically. So we're uniterating it and just turning it back into a vector of list items.
Yep.
And this is just the rest of that function. All right, so this is doing a similar thing to, or wait, no. This is so collect doesn't need the parentheses, I guess. What's the syntax?
My guess, and I'm not really very familiar with this, but my guess is that collect is another one of those generic functions that needs to be given the type that it's collecting into.
Right, but why the
double
colon?
Vec list item needs to be fromable or whatever.
Right. That makes sense. I guess I would have expected something like, oh no, you're right. Okay, I guess that's just the syntax for this. Yeah. This also uses the colon thing.
For passing in the generic.
Yeah, for passing in this thing.
Yep.
Right. Okay. So collecting is just doing what I said, is turning that iterator back into a vector of type list item.
List item now. Yep.
So now we've got the list items, all the valid list items. And then if this is successful, interesting that.
Right. Yep.
Okay, get list response.
Right, because it's a Zome API result of get list responses. Get list response, right?
If this was successful, then return the list. That's, to me, implies that this is checking if it was successful somehow.
Yeah, I think what it means is that if that previous line was successful, if that big blob of stuff was successful, then now we get to return.
But it's only checking here, right? It's only checking if it's successful here. That's interesting to me. Like, why is the question mark here and not anywhere further along?
Is one string of method calls, right? Like that.
Right. So I would why not the question mark again?
One statement.
So you're saying this question mark, you think apply, like this to me looks like if it gets past this and has an error on like the map and can't continue, it's not going to do the question mark.
So this is the nice thing about pure functions. A lot of these things are pure. These maps and these map filters and these collects, they really have no opportunity to fail.
Okay, so yeah, this is the thing that can really do a fatal error. The rest of this stuff is just never going to produce a fatal error.
There's nothing happening from the outside. It's not reading from the database. There's no side effects. There's no nothing. It's just transforming data.
Gotcha. Okay.
There's really no way for that to fail.
Yeah. So if this was successful, if it's here, then we're returning a result, which is going to be okay, because at this point we're sure that it is okay. And what we're going to nest inside of that okay is a call to the get list response thingy, or not a call, but a get list response struct, which is the list name, which is just one of the values of a list entry, I think.
We want to look for struct list.
Oh yeah, that's not what
struct list has
name. That's the only thing in it, in fact. And then the items, the list items that we just grabbed.
Cool.
And there you go. That seems pretty, I mean, makes sense.
Easy and straightforward.
Well, I mean, yeah, it totally, I mean, that
to-do list there is.
There's nothing in there that I don't feel like makes sense, or that I don't understand why it's there.
Some introduction to Rust and some introduction to Holochain, that which there is in that book, is enough to reason through this. Oh, and there's an accompanying article.
Okay. We maybe don't want to read this whole article. No. Or wait, maybe we... No, this is generating it.
Okay, so this is like the follow along with me making this.
Yeah, wait, is this... They just make the whole app here?
Looks like it.
Yeah. Wait, now see, what I want to do now is I want to see if... some zone we created now build if we run hc package. Yeah, what I want to try is I want to try running this little app.
Sure.
If we can figure out how to do that.
It is close. We're close to 4 hours.
Oh, are we? Yeah. 11, 12, 1, 2. Yeah, okay. All right, well, maybe we stop then.
Yeah, I think this is a good point to stop. I think between now and next